Hello everyone, I'm Natasha Pant. I'm here again with you to discuss paper 2 of Open Test 2, the advanced paper 2. And this again falls under the series of Aakash Invictus test series. Alright, let's start the discussion. First section again has 4 single correct. This is our first question. See, in this arrangement, there are 3 voltmeters attached where this information is given to us. The reading of the voltmeters A and B. Along with this, it is mentioned that the voltmeters A, B and C are identical. Okay, so since they are identical, their resistances are going to be same. I am considering them to be R. Now, I am considering here the current is I1. It is I2 here, and in the third one, it is I3. Fine. So, see, first equation, we can use this in the first equation. VA is equal to 7.5, which is equal to I1 into R. Now, similarly, for VB also, we can write 5 volts is equal to I2 into R. Right, this will give us, the ratio of these two is going to give us the value of 7.5 by 5, which is 3 by 2. Okay, this is one step that we got the value over here. Next is, since all these wires are connected across point 1 and point 2. So we can say potential difference across all these elements are going to be same. Alright. So the second equation or the third equation, we can write it using I1 into 9K plus resistance of the voltmeter A. This is equal to I2 into 14K plus resistance of the voltmeter 2. Fine. So I1 and I2, we already know the ratio here. So R, after solving this, R turns out to be 1 kilo ohm. Alright. This is the value of R that we are getting. Now see one more thing. Like since we already know the value of R now, that is 1 kilo ohm. So now the resistance of this branch is 25 kilo ohm and the resistance of top branch is 10 kilo ohm. Okay. So again, we can equate the potentials over here. So I can write 10 kilo ohm into I1 is equal to, this is 25 kilo ohm into I3. So I3 can be calculated as 10 by 25 and this is I1, right? Now see, for I1 we have this data. We already know the value of R. So I can write R is 1 kilo ohm. So therefore, or since we know 7.5 is equal to I1 times of R, that is 1 kilo ohm. So I1 is turning out to be 7.5 milliampere. Right, so if we place this value in this equation, we get I3 as 10 by 25 times of 7.5 milliampere, which gives you a value of 3 milliampere. Alright, so this implies potential difference across the voltmeter C. I3 we know and R also we have calculated. So this is I3 into R, which is turning out to be 3 volts. Okay. So this is the answer for the first question. Alright. Now let's move on to the next question. So see, in the second question, there are 3 wires, 3 charged wires are given to you. All are having the same amount of charge. Okay. We have to find out the net field at the center of the cube. Okay, so I'll take just one wire first. I'll discuss the method of finding out the direction of field, because as we know, all these wires are actually equidistant from the center of the cube. Alright, all these wires are equidistant, and we know one more thing, that if we have a wire which is symmetrically placed about the point from where at which we are supposed to calculate the field, so then the field is always along this perpendicular bisector, right? So in this case, if due to one rod, if I consider the field to be E, the magnitude would be E, then due to all these arrangements, field will have the same magnitude E. Okay. Now I am going to consider the center of this wire, the vertical wire, which is in YZ plane, as P. Its coordinate will be 0, A, 2A. Right. Now the center of this cube, I'm considering this to be suppose point Y. So this point Y will have a coordinate A, A. right? So now since we know the field is going to be along the direction py, all right, so I can write py cap, the unit vector, this is the direction over here. This can be written as a minus 0 I cap plus a minus a j cap, and this is plus, this is going to be a minus 2a k cap. So the value is going to be, since we are trying to find out the unit vector, so I can divide it by the magnitude. This is turning out to be 0, the j component. So this turns out to be 1 by root 2 times of, you can see this is I cap minus k cap. All right, this is the direction of field due to this wire, right? Now similarly, when we find out the field due to wire OA and wire GF, we get the direction, or I can write the net field due to the wire. I'll write the field due to this wire CD first. So this is due to CD. This turns out to be E by root 2 times of I minus K. Now field due to the other wires, all right. So the other wires would be, first is OA wire. Okay, so OA wire, and similarly the other wire is FG wire, right? So I'll write the field due to FG wire first. This is going to be E by root 2. This is minus I minus J. Similarly, we are going to get the field due to the other wire, which was OA wire. That is turning out to be E by root 2 times of, fine, this is plus J plus K. So when you add all these together, so at the center, the point which we considered as Y, the net field is turning out to be 0. It's a repulsive field because of all the wires. Okay, so the answer turns out to be 0 for the second question. Now we have the third question. See, in this we have a soap bubble of mass m, which is blown with the help of a capillary tube. So the surface tension of this soap solution is given as sigma. See, one thing is, it's a soap bubble, right? So since it's a soap bubble, so we can say the number of free surfaces will be 2. Okay. So now, since the number of free surfaces are 2, now we will see what exactly is asked over here. So we are actually trying to, okay, it starts its oscillation because this has been given some charge also, right? You can see sigma is the surface tension over here, right? So you have to find out the value of, we can say, the time period of small oscillations over here, right? Now in this case, see, first of all, whatever charge, we are not sure about that, right? And in the options also we can see that there are no, basically no value of sigma, the charge density or the value of charge present. Okay, so I am going to do one thing over here. First of all, I am going to consider a small element. This is the soap bubble. I am considering a small section of this soap bubble, right? A very small section. This radius is small r. This angle is theta. This angle turns out to be theta again. Fine. I am focusing only on this part now. Now since theta is very small, okay, I can say first of all the radius of this arrangement is r sine theta. The element of concern has the radius of r sine theta. That means this part has radius r sine theta. Now for this element, I am first interested in finding out the relation between the charge of the sphere, okay, or and the charge, this surface tension. We are trying to find that out. So I can see for this arrangement, this is the arrangement that we have. So it is going to experience a force due to surface tension along the tangential direction, right? It is always a tangential force. So the force is going to be along the tangential direction, all right? So now I can write the force due to surface tension is going to be along this direction, along this circumference, all right? And since it's a charged system, so it will be experiencing a force due to its repulsion, that is Fe in the opposite direction, and force due to surface tension, the net value of force due to surface tension as F dash in the opposite, towards negative x-axis. So F dash is equal to Fe. we are solving for equilibrium so that we can find out the relation between the surface, basically surface tension, sigma, and the charge. All right. Now this can be force due to surface tension, if you see, is going to be along the tangent. So we are interested in only the horizontal component here. All right. Because this is being balanced by the Fe component. Fine. So I can write this Fe is equal to, it's the horizontal component. That means I am going to consider this to be, since we already considered the angle over here, so I am going to use the same angle over here. Fine. So just look at it. This is theta. This angle is theta. Fine. So the other angle, this component turns out to be the 90 minus theta. This angle is actually 90 minus theta. So force due to surface tension is actually making an angle 90 minus theta with the horizontal. So the component over here is actually turning out to be sine component, which is equal to force due to surface tension. Now force due to surface tension is sigma multiplied by number of free surfaces multiplied by, this is going to be 2 pi r sine theta. This is the value of f dash that we have. So we can actually simplify this because theta is very small. We can consider it to be theta square. Okay, so this is sigma times of 4 pi multiplied by r into theta square. Right? Because sine theta is very small. So sine square theta will turn out to be theta square. Right? This is the value of force due to surface tension. Now similarly, the force due to the charge present on the system, I can write this as this elemental part that we took, it is experiencing a force Fe. So this force Fe can be written as sigma by 2 epsilon naught. I am considering this to be sigma dash. That is the charge present on the surface charge density of the complete spherical bubble. Alright. This is the field multiplied by the charge of this region, dq. So dq can be written as sigma dash into area of this element, which is pi into r sine theta square or r square sine square theta. Fine. So this is going to give you, see, this is 1 upon 2 epsilon naught. This is going to be pi r square into theta square for the same reason, because we know that this is going to be a very small angle. Now sigma, the charge density, can be written as q upon 4 pi r square to the power 2. Right? This is charge per unit area. Fine. So this turns out to be the value over here. Right? So Fe is going to be equal to, we can see this is turning out to be theta square by 32. Fine. There is q square in the numerator. There is r square in the denominator. 1 pi is getting cancelled. Fine. So this is, and there is 1 epsilon naught. So at equilibrium, at F net is equal to 0, we can write F dash must be equal to the force which is experienced by due to the electrostatic field. So this turns out to be, you can write this as F dash, we already saw the value over here. This is sigma 4 pi r theta square. Okay. So sigma into 4 pi, sigma is surface tension here, into r into theta square. This is turning out to be theta square into q square divided by 32 times of r square pi into epsilon naught. Alright, just we are not going to cancel out any of the terms over here. We are going to leave it in this manner because our answer requires the value of theta sigma. Okay, so that is why we are going to leave the answer in this format only for now. The values in this format. Now, the next part is we are supposed to find out the time period, right? So for time period, we need to find out, we need to equate this equation to the equation of SHM, right? Because the thing is, in order to, like when we see, when this object, when we talk about this object, this elemental part, so it is experiencing a net force due to surface tension towards right and force due to electrostatic attraction, repulsion in the opposite direction, right? So if we write the net force acting on the system, right? So this turns out to be F minus Fe, which is equal to sigma into 4 pi times r into theta square, right? Now this value of r, I am going to consider that this is going to change, right? Because we are actually slightly displacing it from its equilibrium position. Whatever the equilibrium relation was, we are displacing this system, or we are increasing the radius by a small amount, that is dr. All right. This minus, we have this value of theta square q square upon 32 r square pi into epsilon naught. This is what we have. Now, if I actually, instead of r, I can consider it to be dr, r dash suppose, or r1. I can consider it to be r1 also, because we are not talking about the equilibrium value right now. Fine. So this turns out to be, if I differentiate this with respect to r1, right, where dr1 is actually representing the additional gain in radius. Okay. So this turns out to be, you can see, this is sigma into 4 pi theta square, and this is turning out to be, this is r square, r1 square, right? So this is turning out to be minus 2r1 times of theta square q square divided by, rest of the term is going to be, this is r to the power minus 3, right? We are differentiating it, so this turns out to be 32 times of pi into epsilon naught, right? So now this is 4 pi sigma into theta square, and this is going to be plus, you can see this is plus of theta square q square upon 32 pi into r1 cube into epsilon naught, right? Now this value df can be written as directly proportional to the extra length, the increase in radius that it has experienced. Now if you look at this relation and this relation, they are same. If you send this r to the denominator, we are getting this, right? Since dr is representing the change in length, the change in radius, r is actually the radius of the system at equilibrium, right? So this actually gives you dm multiplied by a as equal to, we can actually write this as 4 pi sigma theta square plus 2 times of, again, this value, 4 pi sigma theta square, right, into dr. Now acceleration, as you all can see, is turning out to be 12 pi sigma theta square, right? This is the value that we are getting. Now dr, now I am going to write the value of mass here. Mass is the mass of the elemental part that we have taken. So that is mass upon mass of the complete spherical arrangement. So m upon 4 pi r square multiplied by the area of this part, that is pi into r square theta square, because it's very small, so we can write it as theta square directly. All right. So you can see you are getting the value as, this is going to be, if you send it over here, this is 48 times of pi square into sigma. Theta is getting cancelled over here, right? One of the pi's are getting cancelled, so it's going to be pi only, not pi square. So this is, theta is getting cancelled into sigma divided by m into dr, right? So this is the value. R square is getting cancelled. This is what we have. Now see, when we see, we can see that this acceleration is directly proportional to, the magnitude of acceleration is directly proportional to the increase in length of the radius. All right. If we talk about the direction, when the radius is increasing, okay, when the radius is increasing, so the force due to surface tension is going to increase, okay, but this is going to decrease. So the net restoring force is going to be towards the center. That is why this object is tending to perform simple harmonic motion. All right. Now this complete arrangement, we can compare it to the equation of SHM. This turns out to be omega square. Now using this, we can find out, we had to find out the time period. So the time period turns out to be, as we all are aware of this, time period is equal to 2 pi by omega. All right. We can place this value and then we'll get the answer as C. All right. So this is going to be the result for the third question. Fine. Next. Question number 4. It says that a parallel plate capacitor is filled with two dielectric slabs A and B. All right. Dielectric constants are given to us already, K1 and K2. Conductivities are mentioned to us. So we have to find out the electric field in dielectric slab B. Okay. Now see, I am going to assume the net field in this arrangement as E1 due to all the reasons, whether it is basically whatever the sources are, whether it is the cell that is providing some charge, okay, or the induced charges, the net field inside this dielectric as E1, and for the second one this is E2. All right, I can see one thing in this arrangement, that these two are actually having some potential difference V1 and V2, right? So I can write the value of V1 in terms of E1. Okay, I can write first equation as V is equal to V1 plus V2. This is what we know. Now there's one more thing. Whatever charge is flowing through this, okay, since they are in series combination, so the charge current density over here, or the charge density in when we talk about the current density here, okay, J, that is going to be same for both the elements because the conductivities are given to us, so we can use the relation between current density and the field. Okay, so also we know that J is equal to sigma 1 into E1, which is also equal to sigma 2 times of E2, right? So this gives you E1 as sigma 2 E2 divided by sigma 1. Fine. Now I'm going to use this result over here. V is turning out to be, this is E1 times of D1 plus E2 times of D2, right? So E1 we already can see it is sigma 2 by sigma 1 into E2. This is D1 plus E2 times of D2, right? So when we solve this, we get V sigma 1 upon sigma 2 D1 plus sigma 1 D2. This is the result that we are getting for the fourth question, right? So this is the answer. Okay, so this turns out to be the option A turns out to be the answer for the question number 4. All right. Now let's move on to the next section that has one or more than one correct. Okay. Now see, first is we have a non-conducting ring. Okay. Radius is given to us. We have to find out the net electric field at position O due to all this arrangement. All right. We have to find a few more things. Net potential at point O. See, all the charges, there are equal and opposite positive and negative charges. All right. Or we can say there are equal and opposite charges present over here. So sigma Q, like if I want to solve this, so I can write sigma Q is equal to 0. Because from this point O, all these charges are equidistant. So the total charge is 0. So that means potential is going to be 0 at O, right? Next, let's find out the dipole moment and the electric field. All right. So see, since we are aware of this arrangement, for the arc, like if we have an arc which is subtending an angle theta at the center, so first of all, field is always going to be along the angle bisector over here. All right. So if this angle is theta, so the field over here has a magnitude which is 2k lambda by r into sine theta by 2. This is the formula that we are going to use. So this is a positively charged quadrant. This is the positively charged quadrant. So this is going to dominate the net field due to this first quadrant, and the charge on the third quadrant are actually going to cancel out each other because both are going to act along this angle bisector, right? One of them is acting here, E1, the other is acting over here, right? If we look at the charge densities here, so the charge densities are different. One is half of the other, right? So we can say the net field due to the positively charged arrangement is turning out to be towards this direction, that is making an angle 45 degrees with the y-axis or x-axis. Okay. Now similarly, when we talk about third and second and fourth quadrant, so the net field is going to be present in this direction, that is E2, because this is an attractive. The field is always towards a negative charge. All right. So now we just have to find out the value. As we know, this charge, the net value over here is going to be E1 and E2 will have the same magnitude, okay, because these are opposite to each other. They are trying to reduce the magnetic electric field created by the other part. All right. So we can say E net is going to be root of E1 square plus E2 square. Okay, so E1 and E2 have the same magnitude, so this is going to be E times of root 2. I am considering their magnitude as E. So E can be found out using this result over here. So E net is turning out to be, see, the net field is going to be in this direction because both the angles are same here. This is 45, this is also 45, right? So this turns out to be root 2 times of, now I'll place the value here, 2k lambda, the difference of these two densities we have taken, that is lambda upon r, right, multiplied by sine pi by 4. All right, so this is going to be equal to 1 by root 2. Direction is towards minus I cap. The value of E net is turning out to be, you can see this is cancelling out. So k has a value 1 upon 4 pi epsilon naught. So this turns out to be 2 pi epsilon naught, okay, multiplied by the value of lambda. We have to find out the answer in terms of lambda only. This is the result, all right. So this is the value of E net and the direction is minus I cap, fine. So A option will also be correct in this part. Now, the ring is, okay, we have to see this also. The electric dipole moment of the ring, all right. So in order to find out the electric dipole, let us consider an element. This is the arrangement given to us. Okay, so now I am considering a positive charge plus dq here, okay, and just opposite to it there is a negative charge because the charge densities are already known to us. This is plus 2 lambda, this is minus lambda, plus lambda, fine. So I am considering this as a dipole over here, right. So in this dipole, I can see the dipole moment is going to be towards I cap dp1 vector, right. So now this charge that I have taken, I am assuming it is subtending an angle. It is making an angle theta with the vertical and it is subtending an angle d theta at this position. So the same thing goes with the other part also, right. Now let's find out the value over here. See, dp, we have to find out the dipole moment only. So dp is equal to the charge, that is dq, present on this, for this dipole, and the separation between them. Since the radius is capital R over here, so I can write this distance is 2 times of r sine theta. Alright, so this is the value of dp. Now dq can be written as the charge density 2 lambda multiplied by this r d theta. Alright, this, and this is 2r sine theta. Fine, this is dp. So if we integrate this arrangement, we are getting the dipole moment for the upper part of the basically arrangement where the charge densities are plus 2 and minus 2 lambda. Alright, so this gives you, I'll keep this 2 lambda outside only. Alright, so this is going to give you r square. And this is going to be equal to, we can consider this to be 2 times of sine theta d theta. Is that all right? So this is going to give you a value. This is from 0 to pi by 2. This is what we are considering over here. Fine. So the final answer that you get from here is 4 lambda r square. And the direction of dipole moment for the upper part of this ring is going to be towards I cap. Okay. So see, this actually makes it easier. This was negative, this was positive, plus 2 lambda. Fine, so that means the upper part has a net dipole moment of P1 vector, whereas when you look at the part below, its density is actually, charge density is half, alright. So dipole moment is also going to be half over here. So the dipole moment due to the lower part is going to be P2, right. So I can write P net is going to be equal to, this is 4 lambda r square minus 2 lambda r square, and the direction would be, the net value is going to be in this manner. Fine, so this is 2 lambda r square I cap. Fine. So you can see this is given as 3, so this option cannot be correct. Now, if the ring is placed in a uniform electric field E, which is along x-axis, all right, then the ring is in translational and rotational equilibrium, right? See, translational equilibrium is definitely going to be present over here because equal, same amount of positive and negative charges are present here, okay? So now when we talk about the rotational equilibrium, so net dipole moment is along I cap and electric field is also along I cap. So the torque is going to be 0, right? It is P cross E. So this is going to be 0. This implies that the system is going to be in the translational and rotational equilibrium as well. Fine. So the answer here is going to be A, B and D. Okay. Now let's move on to the next part. Question number 6. A cylindrical conductor has a resistance R. Fine. And it has been given the radiation is decided by, for that conductor, radiation is decided by this result, which is the Newton's law of cooling. Along with this, the heat capacity of the conductor is given to you. Okay. Now we have to find out, there's one more information, that at an initial temperature, the temperature is T naught. Okay, at T equal to 0, the temperature is T naught. Fine. So temperature of the conductor in steady state we are supposed to calculate. See, if this is a conductor, it is connected to a cell. This conductor has resistance R, right? So whatever energy or whatever energy per unit time is given by the system, whatever energy, it is getting absorbed in the system, which is responsible for increasing the temperature of the object. Okay. Along with this, some amount is getting radiated. So that is decided by this, the radiated part. All right. So I can write energy per unit time, that is power. V square by R is the power per unit time energy provided. Now the amount absorbed part will be dependent on heat capacity upon dt, because this is energy per unit time, plus the amount of heat radiated, right? Newton's law of cooling, this is the amount of heat radiated per unit time. So this is K times of T minus T naught. So it says that at steady state means this object is not absorbing, basically this object is not increasing its temperature, all right. So that means dt turns out to be 0. At steady state, we can write V square by KR, RK is equal to T minus T naught. Okay, so this gives you a value of steady state temperature as T naught plus V square by KR. Fine, that's correct. Now, temperature after a long time is equal to the temperature of the, no, see, steady state temperature is this, right? So that means the temperature cannot be T naught after a long time. Next is at T equal to 0, no heat is lost to the surrounding. So at T equal to 0, at initial temperature is mentioned as T naught. So that means Q, which is equal to K times of T naught minus T naught, right? So this is turning out to be 0. That means there is no loss to the surrounding, no radiation loss to the surrounding. Maximum, it's wrong because it cannot be maximum heat lost. The temperature is T naught at T equal to 0. All right. Now, question number 7. So A and C are the correct options. Next is, this network actually consists of a rheostat which is having actually a variable resistance, right? So see, first of all, we have to find out minimum value of, see, value of n for which the reading of the ammeter is maximum or minimum. This is what you are supposed to calculate. So if I consider for maximum, okay, it's given eta equal to 0. So first is eta equal to 0 means we are getting the arrangement as this. I am considering this as the element over here, ammeter. This is the resistor. This is E. There is no potential, there is no resistance over here. The complete resistance R naught is present on the other side, right? Now here we have this as the arrangement, right? So when you look at this part, whether it is n equal to 0 or n equal to or eta equal to 1, when it is eta equal to 1, this R naught will be on the other side, fine, and there on the right hand side there won't be any resistance present. Fine. So in both the cases we can see, if I consider the potential at this position to be 0, so potential here turns out to be 0 volts. Potential at the bottommost position is E, then this turns out to be E. So you can see maximum potential difference is actually through the ammeter, or through the resistor maximum current is flowing. So that means ammeter is going to give you the maximum reading whether it is eta equal to 0 or eta equal to 1. Okay. Now we want to find out the value for minimum. So for minimum, I am going to consider this arrangement only. This is eta R naught. The remaining turns out to be 1 minus eta times of R naught. Alright. So if you look at this, on the left side of this branch, there is E and one resistor. On the right side of this branch, there is E and another resistor, right? So these these two cells are actually in parallel combination. So we can find out the effective value, okay? So E effective is going to be E upon N R naught plus E upon 1 minus N R naught whole upon 1 by N R naught. This is the result for parallel combination of cells, right? So you can see this is actually turning out to be E, because if you take E common, you're getting the value as E. All right. Now we are interested in finding out the maximum current. So I am actually going to replace this complete arrangement by small r effective, and this is a cell of EMF E. There is a resistor capital R, right? Now the small r effective we are interested in calculating. So small r effective is equal to, you can write this as N into R naught, right? That was the parallel combination, into 1 minus N into R naught whole divided by R naught. Fine. So this is going to give you the value of current as E divided by R plus small r effective, right? So in order to find out the minimum current, we can see that we can just differentiate this part, because this is the part which is actually creating a difference over here. All right. So I can write, I'm going to differentiate this, dr effective by dn. This is going to give you, see R naught, one of the R naughts is getting cancelled over here, right? And we are going to get 1 minus 2 times of n. So this is going to be 0 when this eta is equal to 1 by 2. On differentiation, we are applying the concept of maxima minima. So this is going to differentiate to get you a value 0 when n is equal to 1 by 2. Right. So this implies that the minimum current is going to be present when eta is equal to 1 by 2. All right. So the answer to this question turns out to be this, A, B and C. Now this is the question where you might have got stuck. Fine. So let's discuss this question. See, in this arrangement, we are actually supposed to, this dipole, if you look at these options over here, first two are actually asking you in which direction the field can be present. And the next two options are actually the work required to slowly rotate the dipole by an angle pi by 2. All right. And that too in clockwise sense. So we know one thing, like initial dipole moment of this arrangement is pi cap plus pj cap, right? Now when it is rotated, so that means one part of the dipole, one component will be towards negative y-axis, the other component is going to be towards positive y-axis, positive x-axis. All right. So this gives you the final dipole moment as pi minus pj. This is the dipole moment for the initial part and the final part, right? I am interested in finding out the field, and we also have to find out the work done. So see, work done has just one formula. I can write the change in potential energy of the system. Okay, this turns out to be P final, or I can write this as, okay, so this is going to be final value, that is U final minus U initial. Okay, so now U final is equal to minus P final, that is P final dot E, right? There's a negative sign over here. Yeah. I've already put the negative sign. So this is minus P final dot E minus of minus P final P initial dot E. This is what we are supposed to calculate. So if you see, there is no change in the x component over here, and the field, whatever field is created by this element is going to be same, okay, even if you rotate the dipole. So we can actually say that the change is actually coming out in the j component over here. So this is turning out to be 2 times of p into, this is going to be p dot e vector. All right. So this is 2 times because it's getting twice of the value over here, right? So now this is delta U. This is the change in potential energy. Let's find out the value of E first, then we'll be able to find out the net work done and the direction of field. So see, in this question, first of all, just try to understand, like if I take this element, I am interested in finding out the field at this position. This distance is already known to us. This is given as root 3r, all right. So if this distance is root 3r, this complete distance is capital R, so I can write the distance of the topmost point to this point turns out to be 2r. So we already know this angle now. I'll consider this to be alpha. So alpha is turning out to be 30 degrees. All right, this is what we know. Fine. Now, I am taking an element over here. So this element which is making an angle theta with the y-axis. Fine. So see, first of all, understand this arrangement. This arrangement is somewhat like this. The ring is actually, the part of the ring is present in a plane perpendicular to the axis. That means perpendicular to x-axis. Okay. So whatever element we are taking will have a component in such a way that its component is going to be out of the plane. All right. So if we consider this element, so this element will have a component of field. Whatever the field is, its one component is going to be E along x-axis, dE along x-axis. Okay. Now along with this, if I consider this to be z-axis, the next component, this angle was alpha, so I can write d along x-axis as dE. This is going to be the cos component, cos alpha, right? Because the net field is along this direction. Fine. So this angle is alpha, so this turns out to be dE cos alpha. So the component which is lying between y and z-axis is going to be dE sin alpha. Right. See, actually the thing is, when I talk about the point over here, right, consider this to be the plane where a triangle lying on y-axis, x-axis and passing through origin is actually present, right? When you rotate this by an angle theta, why are we rotating it? Because the point that we have taken is into the plane. So if it is into the plane, so this component, the sine component is going to be out of the plane, okay? So that means it is going to make an angle theta with the vertical axis. So the vertical component, y component is turning out to be dE sin theta, sin alpha, and this is cos theta. So the projection on y-axis is turning out to be this. This is dEy, whereas the projection on z-axis is going to be dE sin alpha, and this is going to be theta. This is going to be the sin theta component, right? So we are actually getting integral dEz as integration of dE cos, dE sin alpha. Alpha is known to us, okay? Sin theta. So for the z-axis, when we integrate it, we get the net value as 0. But when I talk about this vertical component and the horizontal component, that is along x-axis, so we can write this as integral of dE cos alpha simply. All right. Similarly, component along y-axis is turning out to be integral dE. This sine component was broken down into its cos part. The reason behind this was when we are talking about an element which is into the plane. Okay. So this component of the, basically the vertical component, the component E sin theta sine alpha is not going to change it's not going to change, basically it's going to make an angle theta with the vertical axis, right? Because it is moving out of the plane, fine. Now, when we try to solve this, we can actually see DE along x-axis, we are integrating it to get the field along positive direction of x-axis, okay? So this is along I cap. I'm just interested in magnitude over here. So E along x-axis is going to be integral of k into dq, that is the charge present over here, divided by 2r square, okay? This is the field multiplied by cos 30. So this component, after solving this, we can actually see that this turns out to be root 3 by 8 times of k into q divided by r square. This is along x-axis. Now for y-axis, EY is turning out to be integral of, I'm placing the value of dE, which is k into dq again, the charge which is present, upon 2 r square. Now this is sine 30. Sine 30 is 1 by 2. Alright. Now this turns out to be, there is another cos theta. Fine. Now dq can be put over here. So we get the value as 3 by 8 times of k into q divided by pi r square. As we know that dq can be written as lambda, okay, upon the arc length. Basically this is dq, this is turning out to be lambda into rd theta, that is the length of the element that we have taken over here, right? And lambda, as we all are aware of this, lambda can be written as total charge present on this arrangement, which is, this is going to be pi by 3 times of r, right? So we are getting this value when we are placing the limits from minus pi by 6 to plus pi by 6, right? This is the net field. So see, the net field is actually going to be root 3 by 8 times of kq by r square, which is I cap, and towards negative y-axis, because the vertical component is vertically downwards, minus j cap, along minus j cap. So this is turning out to be 3kq by 8 pi r square, right? Now you were supposed to see the field is only along x and y-axis, okay? Now the change in potential energy you were supposed to find out. So that field, we are talking only about the y component over here, right? Because the x component was not changing. Okay, so this is turning out to be minus 2 times of p into 3kq divided by 8 pi r square. This is the change in potential energy experienced by the basically work done by an external agent in slowly rotating this dipole. All right. Next, so the answer for this part turns out to be D option and the option B. All right. Now let's move on to the next part, that is the numerical value type questions. Okay. So see, there are 8 questions in this section. This is the first one. All right. See, in this question it says that when you are connecting an ammeter, this is the reading between points P and Q, and when you are connecting a voltmeter, so the reading is 70 volts. All right. So we are going to do one thing. I am going to solve for this circuit. Basically, I am going to solve for the voltmeter part right now, because even if I place a voltmeter here, this circuit is not going to change because there is no division of current over here. Okay. So first of all, I am going to assume, like since this I current is given to us, I am going to consider the same current I is flowing through this part. Okay. Now we have been given the potential difference between P and Q point. So I can write the first equation as potential at Q minus potential at P as equal to 70. This is what we have. Now if I assume this point to be at 0 volts, okay, so the other point turns out to be at, I can consider the other point turns out to be at 210 volts. All right. So see, this point was VQ, this point is VP. All right. So I can say potential difference over here is I into R1 and this part is I into R2. So this is I into R1 minus I into R2 is equal to 70. So we're getting a relation R1 minus R2 is equal to 70. This is the first relation that we can actually write over here. Okay. Now the next part, I am going to apply KVL in this loop. Alright. So this is 210. 210 can actually be written as I times of R1 plus R2. Okay. So now we can see that we are getting this complete arrangement. This is the equation that we have. Okay. So in this equation, we can see 210 divided by I is going to give you a value of R1 plus R2. All right. This is I into R1 minus R2 is equal to 70, and the other part is turning out to be 210 by I is equal to R1 plus R2. All right. Now in this case, if I just replace the value of I over here, so we will get, see in this case, if I just place I as 70 by R1 plus R2, so we are going to get R1 is equal to 2 times of R2. This is what we require using equation number 1 and equation number 2. All right. Now next it mentions that the reading of the ammeter, fine. That means we have a resistor here R1. There is another resistor R2. Okay, and this ammeter is experiencing a current of 10.5 amperes. This is R1. This part is R2 again. Fine, this is what we have. Now see, I can see in any of the branches, if I consider this to be I1, this as I2, I'm breaking the current over here. So we already know this relation. So I can write in this loop, I1 times R1 is equal to I2 times R2. Fine. So this gives you a relation between I1 and I2. All right. I1 is equal to 2 times of I1, R1. So this is I1 times 2 is equal to I2. This is what we are getting. This is the second relation that we have. Now again, if you see, this current was I1, this current is I2. The reason is this is a reciprocal circuit. Okay, this R1 and this R1 are going to experience the same amount of current, and the same thing goes with the other R2s also. So I can write this I2 according to KCL, that is the for this particular branch. Okay, the amount of current entering, that is I2, should be equal to 10.5 plus I1. So see, this is going to give you the value of I1 as 10.5. Right, this is what we have here. Now since we already know the value of I1, okay, we already know the value of I1, so that means we already know the value of current which is flowing through this branch as well. All right, so now we can actually apply KVL. Since I am considering this to be at 0 volts, the other part, I am assuming this to be at 210 volts because it is given to us in the situation. So the potential difference across this branch is going to be 210 only. So we can get an additional equation here, that is 210 minus I2 R2. Okay, this is minus I1 R1 is equal to 0. We know that this R1, okay, we can, if we replace it by R1, 2R2, okay, this is going to be 210 minus 2 times of I1, okay, into R2 minus I1 into this is equal to 0. So this gives you the value of R1 as, I can write this value of R1 as, this is going to turn out to be 10 ohms. Okay, because we have replaced this 2R2 as R1. Okay, so this is 210 divided by 2 times of I1 is equal to R2. All right, so this is the value of R1 that we are getting. So now our final circuit is, we have to replace this, we have to place a wire of resistance 10 ohms between R1 and R2, or between point P and Q. This is 5, this turns out to be 10, this is also 5, this turns out to be 10 again. तो देखो जब आपने इसको ऐसे कनेक्ट किया है, so again we have this circuit, this is 210, alright. So see, again I am going to assume a few values here. I am considering, okay, so I am considering at this position, since again this is a reciprocal circuit, fine. So I can write potential at this position as V, this as V minus V1, okay, this as 0 I am assuming. So this turns out to be V1, fine. So whatever amount of current is entering to this node where the potential is V1, okay, some amount is getting actually, basically it's getting divided into two parts. So this is whatever the current is, it's getting divided into two parts. So again I can write sigma I is equal to 0 at a node. So this turns out to be V minus V1 upon 5 is equal to V1 minus of V minus V1 upon 10 plus this is going to be V1 minus 0 upon 10, right? So when we solve this equation, fine, so we are going to get the value of V1 as, this is going to be equal to, we have to find out the current in this branch, alright, so this is turning out to be 126 volts, because here as V, since I have taken it as 0, so we will have a value which is 210 volts. Alright, place this value, we are going to get this. Okay. Now, our aim was to find out the current through the branch which is connected between P and Q. Okay. So, current can be found out by finding out, this is current through the branch PQ. This can be written as V1 minus V minus V1 divided by 10, okay. So when you place this value, this is actually 2 times of V1 minus V upon 10, alright. V1 is 210, V is 210 and V1 is equal to 126. So you get the answer for the current as 4.2 amperes after solving this equation, alright. Now, let's move on. So the answer here is 4.2 amperes, alright. Let's move on to the next question. Okay. So in a gravity-free cabin, there is a non-conducting liquid of surface tension sigma, alright. It possesses a uniform charge density rho, which is given to us, okay. Now if the radius is this, okay, we have to find out the value of alpha if this is the radius of the system, alright. So now in this case, see, first of all, if I consider a region, whatever the spray is, whatever liquid is being sprayed over there, alright. So that liquid will be occupying some volume V if I consider. So there will be continuously, these are going to break and they are going to coalesce together, right? They are going to combine together or break together, fine. So now, since this question says that this system has to reach a stable value, okay. So by stability, we know, by stability, we actually mean one thing, that the potential energy of the system must be minimum. This is what we have, right? So we just have to write the potential energy for one of the objects, one of the drops over here, okay. Since we are considering the volume to be V, so I am considering potential energy per unit volume as, for one droplet, potential energy for one droplet would be potential energy due to, basically this is the surface energy, okay. And along with the surface energy, there will be some self energy. So these are the droplets. Droplets means they are actually acting as basically they are acting as a non-conducting material of some charge density, rho, which is given to us, divided by volume of one droplet. This value is for one droplet. One drop, it stays at equilibrium, or it gains stability when its total energy per unit volume, or we can write when its total energy, total potential energy is going to be constant. So I am focusing on this drop of radius r. Its energy I have written upon its volume. This is going to be U by V. Alright. Now see, we need to find out, we need to write the value over here. We need to find out the radius of a stable arrangement. Okay. So for that arrangement, I am going to write the values over here first. Potential energy per unit volume is going to be surface energy. Surface energy will be sigma naught, that is the surface tension, sigma surface tension, multiplied by the surface area, 4 pi into r square, alright, plus for a non-conducting solid sphere, okay, the surface self energy is 3 by 20 times of q square upon, this is pi epsilon naught into r, right. This is going to give you 4 by 3 pi into r cube. This is divided by 4 by 3 pi into r cube, okay. Energy per unit volume, okay. So now, when we rearrange this, I can actually write potential energy as V times of, I'm going to separate these terms. So this is going to be V multiplied by 3 sigma upon r, 4 pi is getting cancelled. Over there, we are going to get, you can see, this is going to be 9 by 4 times of pi into r cube, okay, and here we have 20 times of pi into sigma naught into r. Now there's one more thing, I'm going to place the value of q also, okay. So charge can be written as, this can be written as charge multiplied by volume, 4 by charge density multiplied by volume, okay, square of this term. Fine, so since we have this square of this term over here, right, so I can see for this arrangement, this is the total potential energy of the system present, alright, volume multiplied by potential energy per unit volume for a single drop, okay. Now, when we actually solve this equation, yes, we get the potential energy as V times of, this was 3 sigma by r, okay, and plus, if you see over here, this is r to the power 6 and there is r to the power 4 here. So we are getting r square in the numerator over here, alright. So this is going to give you, alright, this is going to give you 1 upon 5 times of rho square into r square upon epsilon naught, right. This is what we are getting. Fine, when we cancel all these terms, this is rho square, this is what we are getting. So now du by dr should be minimum. So we can take its slope for this graph, du by dr should be 0. Okay, u should be minimum for this, du by dr should be 0. So this actually turns out to be, you can see, we can write 3 sigma by r, okay. If we actually try to integrate this one, differentiate it, this is what we have, right. So this is going to give you a result, I'm going to write it directly over here, 0 equal to 3 sigma into minus 1 by r square, okay. This is plus 2 by 5 into rho square into r upon epsilon naught. So on solving this, you actually get the value of r cube, alright. So this is turning out to be 15 by 2 times of, fine, this is going to be epsilon naught multiplied by, epsilon naught into sigma divided by rho square. This is what we have. So the answer turns out to be 15 by 2, that is 7.5, okay. So this is the answer that we are getting for the next part, alright. Next, let's move on to this question. See, so Littleton and Bondi suggested that the expansion of universe could be explained. Alright, see, this is the charge of the hydrogen atom, okay, and here we have been given, like suppose if we have this arrangement, so it has number density is given to us, alright. So number of atoms or number of charges can be written as n multiplied by 4 by 3 pi r cube. This is what we have. So see, if I talk about the charge of this arrangement, so charge would be number of, if I talk about just one charge over here, okay, charge of an atom, if this is an atom, okay, so charge of an atom means it will be having the proton of that charge and some electrons also. So the net charge Q net turns out to be 1 plus YE minus E, the charge of an electron over here, so this turns out to be Y times of E, okay. Now see, the expansion is going to take place only when we see this arrangement, like if this is a positively charged, the net positively charged arrangement. So this atom is going to experience a force in the, that is due to the electrostatic force, and this is the force due to gravity. Okay, expansion is going to take place when this electrostatic force is dominating. Fe is greater than equal to the gravitational pull. All right. So now this electrostatic force can be written as, I can write this as K times of, K is 1 upon 4 pi epsilon naught multiplied by charge. Okay, number of charges in this arrangement multiplied by charge of this complete universe, right? This multiplied by the charge of one atom, that is Y into E, right, divided by R square. This should be greater than equal to G multiplied by this complete universe's mass, which is equal to N into mass of proton, okay, and multiplied by the mass of this arrangement, this atom, that is mp upon R square, right? So see, this will give you a critical value of Y square is actually going to give you, N is getting cancelled, we are going to get the value of G into 4 pi epsilon naught into mp square upon me square, right? So when we take the root, we will get the result of the system as around 8.71. All right, this is the answer to this question, 11th. Now, see, question number 12, right? So now, when we talk about this in this arrangement, see, first of all, when we are closing these switches, okay, so I am assuming that Q charge is flowing through this. Some part of charge is over here, Q1, the other part is over here, Q2, right? So on this plate, I am getting plus 4 Q0 plus Q1. Now over here, I am going to get negative and positive are present in this manner. So this is going to be 12 Q0 minus Q2. The charges after closing these switches I am getting. Now here again plus and minus are given to us. So this is 9 Q0 plus Q. This is what we have. So see, we have to write the equations here to find out this value. Okay. So first equation that I am writing over here, this turns out to be E minus I into R. Okay. This minus, this is going to be 4. I am taking this branch. Okay, the current charge is flowing through this branch. So this turns out to be minus 4 Q0 by 2C. This is going to be minus Q1 by 2C. Okay. And then for the branch over here, this is going to be minus 9 Q0 by 3C. Okay, and minus Q by 3C. This is going to give you the value of Q1 as 2C times of E minus IR. All right. And this is, see, this is 2, and this is going to give you 5 Q0 by C. Okay, and there will be a minus Q0 by 3C on the other side. Fine. Similarly, when we talk about the other part, the other branch, connecting the battery, the other capacitor over here, so this turns out to be E minus I times of R. All right. This is plus 12 Q0 by 4C. Okay. And this gives you, this is what we have, okay. So now this is going to be minus of Q2 divided by 4C, okay, and the other part is going to be minus 9 Q0 by 3C minus Q by, this is going to give you a value of 3C. This turns out to be 0. So Q2 from this equation is 4C times of E minus IR, okay. Along with this, we can see these are getting cancelled. So we are going to get this as minus of 4C times of Q by 3C. This is getting cancelled. Now see, we know one more thing. Q1 plus Q2 is going to give you a value of Q, where Q is actually turning out to be, when you add these equations, we are actually going to get, this is 2 times of C into E, all right, E minus I into R, all right. Now, when we add these two equations, fine, so this is turning out to be, see, this is 4 by 3, okay? And here we have 10 Q naught by C, right? So this is turning out to be minus of 10 Q naught. This is the equation that we are getting when we are adding all these values, because Q1 plus Q2 is going to give you a value of Q, okay? Now we are going to just rearrange this and then we'll get the value of, this is 3 times of Q naught. So we are going to get Q is equal to 2 CE by 3, okay? Now there is minus, this is 2 by 3 times of C into I into R, alright? Okay. Now along with this we have, there is a minus 10 Q naught by 3. This is the value that we are getting, okay? This was actually, this is what we are getting, okay? Because the value over here is turning out to be, there's just a small change, it's going to be 10 by 3 in this side, okay? So now, since we have got this value, so see, I can write, first of all, 2 times of C into E minus 10 by 3 times of Q naught, okay? This minus Q is equal to, this is going to give you I, for I can write this as dQ by dt, and this is turning out to be 2 times of I into R, alright? 2 times of C into R. So now we have this equation, dQ divided by 2 CE minus Q naught into 10 by 3, okay, minus Q. We are integrating this, and this is dt upon 2 RC. So when we integrate this, we get the value of Q as, this is going to be 2 CE minus 10 by 3 times of Q naught into 1 minus e to the power minus t by 2 RC, right? But we are supposed to calculate the value of current here. So current is dQ by dt. This is the value of current. So see, we just need to divide it by 2 CR. So this is 2 CE by 2 CR minus 10 by 3. This is 2 CR, and there is a Q naught over here. And the remaining equation remains the same. Fine. So see, we have to find out the relation between alpha. Okay, we just have to find out alpha plus beta here. So alpha is equal to 1, beta is equal to, this is turning out to be 5 by 3. So the answer is 1 plus 5 by 3. This is the answer to this question, okay? Next. Now, see, the answer is turning out to be 2.67. Fine. Now we are going to move on to the next question, that is question number 13, right? See, this question has, initially हमने यहाँ पे charge ही दिया हुआ है, so you can see this is plus Q, minus Q will appear over here. फिर on this surface already 3 था, so this turns out to be 4Q minus 4Q. Then on the other side already 5Q था, तो plus 9Q, ठीक है? Now see, when you are connecting this to earth, so earth का काम क्या होता है? It is going to make the potential at all the points as 0, ठीक है? When this system is connected, potential turns out to be 0. So see, तो अब जो charge रहेगा, this is going to be Q, and on this surface, the surface of radius 2r, okay? There will be minus Q. Rest all the surfaces which are present beyond, okay? The net potential at this position, this, and all the other positions, potential is going to be 0, alright? So this implies only these two charges are remaining. So the energy is going to be stored. There is some energy over here. Finally also there will be some energy over here, alright? We have to find out the heat dissipated. Heat dissipated का मतलब, we need to find out the energy जो पहले इस region में stored थी. Also the energy which is stored between the outermost surface and r equal to infinity. हमें U2 और U3 का value निकालना है. That is the amount of heat which is dissipated. Alright. So I can write, for this I am going to use the concept of energy density. Okay. So heat dissipated is going to be the heat U2 plus U3. So I am going to write the total energy dissipated is going to be, this is half of epsilon naught and this is going to be E1. Okay, so energy, the field in this region, field between the second and the third shell, I'm considering this to be E2, and the field here is E3. All right, so this turns out to be integral of K into 4Q square. Okay, because I have to find out the net field, so I'll just write the value of E over here. So this is turning out to be K into 4Q divided by whatever the radius is. I am considering its radius to be, suppose, smaller. Okay, so this turns out to be KQ by R square. Okay, now the volume, this is, I'm using the formula of energy density. So du by dV is equal to half of epsilon naught into field square, right? So now the volume over here is going to be 4 pi into R square dr. So when we are using this, the limits are from between this region. This is 4R to 6R. Okay, 4R to 6R. 4R to 6R. Now similarly, for the other part also, we are going to write this as integral of K into, the value is 9 Q upon R square. This is whole square, and the area is again, the volume is 4 pi R square dr, right? So this value extends from 8R to infinity, right? When we solve this equation, we get the total amount of heat dissipated, because there is no energy. Whatever energy was stored here has been lost because the charge has moved out. Fine. So the total answer after solving this equation turns out to be 5.73. All right. This is the value that we are getting. Now let's move on to the next question. Question number 14. Okay. So see, this question has this. Due to a square plate, the potential at the center. See, potential at position A will be directly proportional to the charge which is present over here upon the dimensions over here. All right. So I can write this as some constant K, suppose, any random constant K. Okay. Now charge is dependent on area. It's a surface charge density. So I can write this as A square by A, whatever the constant is. So this is given as 2 K times of A. This is one of the relations that we have, because VA is given as 2 volts. Now, when the charge is on the outermost surface, okay, so that means potential at B is also, we can write this as some constant multiplied by the dimension of this arrangement. So this is turning out to be A, and this value is given as 12. Now see, we have to find out the potential here. So when we are supposed to find out the potential here, so we can actually take 8 cubes. 8 cubes imply the side of each cube is going to be 2A. We are going to keep 1 cube over the other. All right. So there are 8 cubes which are giving you a few common surfaces which are passing through the center. Like this is one surface, this is another surface, third surface, fourth surface. So these are the surfaces which are carrying the charge, okay? And along with this, there are 2 more surfaces present here. When you are joining these 8 cubes, these 6 surfaces are passing through the center, all right? So I can write potential due to this cube is going to be equal to potential due to the 6 surfaces, right? I'm considering this to be 1 plus V2. Now see, V1 is going to be due to the 6 surfaces, and these plates, as you know, of side A had potential 2, right? But when the size is doubled, so this turns out to be 2 times of, I can write this as 2 times of K into A, right? So K into A, we already know it as 2, so this turns out to be 24 volts. This is because of the 6 surfaces, 1, 2, 3, 4, 5 and 6. Similarly, when we talk about V2, V2 is the potential which is because of the outermost box over here. So the outermost box, when it was of size A, potential was 12, but now the size of this arrangement has increased, it's doubled. So this turns out to be 24 volts. Okay, so this implies the net potential V net is turning out to be the sum of them, that is 48 volts. But this is the net potential due to 8 cubes. We want the answer because of 1 cube. Okay. So now, this gives you the potential due to 1 cube as, this is 48 by 8. That is equal to 6 volts. Alright. This is the answer for the question number 14, 6 volts. This is the answer. Now, let's move on to this question, question number 15. See, in this question, we have to find out the maximum power across this arrangement, is this resistor. So again, see, I can see that these two are in parallel combination, okay, the cells. So effective EMF turns out to be 15 by 2, and this is of opposite polarity, minus 5 by 2 divided by 1 by 2 plus 1 by 2. This gives you 10 by 2, that is 5 volts, okay. And the effective resistance, effective internal resistance is going to be 1 ohm. Alright. So see, we can actually draw this arrangement as this. This is 1 ohm. The other one is 5 volt. Okay. Now, this is a variable resistor. Fine. So if this is a variable resistor, and if I consider Rx to be 0. Okay. So if the resistor Rx, resistance Rx is 0, so this resistance will not have any role because there is no potential difference. Okay, this point, whatever potential this point is having, X, the same potential will be for all the points over here because we are considering that the rheostat is at having 0 resistance. Okay, so this gives you a simple circuit as this, 5 volts, 1 ohm, 2 ohm. Okay, now we have to find out the maximum power across this arrangement. So maximum power will be, we can actually write for this system, I can write this as current, that is I upon 3 square. This is the current which is flowing through this, multiplied by 2. So this is going to give you the answer which is turning out to be 5.56 watts. Alright. This is the answer for this question, number 15. Now the last question. Okay. Now see, in this question, when S1 and S2 both are closed, okay, so we have to find out the heat lost. Alright. So see, if I see when there is no, even if I don't draw the resistance over here, it won't affect the arrangement. The reason behind this is, we can see whatever charge redistribution has to happen, will happen, and as soon as the charge gets redistributed, we will see that there will be no current through the resistor. So we can ignore that. Okay. So each and every capacitor has the same capacitance. Now, since these are in parallel combination, I can assume the charges on them to be Q. Fine. Now see, I am going to look at these plates. The plates which are connected on the left hand side. These plates are not connected to any cell, any source of charge. So we can say these plates are isolated. So the initial charge on this plate, Q initial, all these plates were having plus Q, minus plus 10, minus 10 and plus 10. So the total charge was 10. So this 10 coulomb is going to get redistributed amongst these 3 capacitors. So Q final is turning out to be 3 times of Q, right? So since these are isolated, so we can say the total charge over here is going to be conserved, which implies 10 is equal to 3Q, which actually gives you Q as 10 by 3. So we have found out the value now. We have to find out the amount of heat dissipated. So we can find out the potential energy in the initial stage and the potential energy in the final stage. So the potential energy in the final stage will be, this is Q square by 2C for one capacitor. There are 3 capacitors, so multiplied by 3. Similarly, potential energy for the initial stage would be, see, each and every capacitor has the same amount of charge because they have been charged to same potential difference, and C is also same. So this is Q naught square by 2C multiplied by 3. The reason why we are writing it as Q naught, because we already know the value of Q naught. Q naught is equal to C multiplied by V, 20 microfarad. Right? So we can now find out the difference over here to find out the energy. So heat lost. Okay, so this is heat lost can be written as delta U. Just a minute, yeah. So this is heat lost. This turns out to be U initial minus U final. U initial is Q naught square by 2C into 3 minus initial was Q, final was Q initial, Q naught square by Q square by 2C into 3, right? So this gives you a value of, you can see 3 by 2C can be taken outside, Q naught square can be taken outside, this will be 1 minus, since Q was equal to Q naught by 3. So this is 1 upon 9, okay? When we place the value of Q naught and when we solve this, we get the answer as this, 0.27 millijoules as the answer, all right? So this was the end of the paper here, okay? So actually this paper was, see, the thing is, when we, this paper was quite lengthy, all right? So there were some questions which were lengthy and there were some questions which were comparatively easier, right? But the paper was actually a mixed balance, okay? So let's end this now. Thank you everyone. I would like to request Vipul Duggal sir for the chemistry discussion now.
Thank you ma'am, thank you.
So.
It was really a beautiful session. I hope the students has got all the answer to their queries. So how was the physics paper 2 ma'am?
It was difficult. It was difficult, more difficult than the previous one.
Okay.
That was paper 1. And it had some lengthy questions where you need to do some calculations and some concepts were totally new, right?
Okay.
So that is why I would request all the students to join in for the Aakash Invictus test series. This is going to benefit them for the
exactly.
preparation next year.
Yeah.
Okay, so
thank you ma'am.
Okay, thank you everyone.
So hello everyone, once again. I'm here to discuss the chemistry paper 2 of JEE Advanced Open Test 2. My name is Vipul Duggal. I'm a chemistry faculty at Aakash Invictus. So let's start the session. So this is a paper 2. This is a section 1. It has 4 single correct questions. Let's start. Okay. The very first reactant, we can see here that this is the oxime given in the reaction, and we know that how the oxime reacts with the PCl5. So पहले ही बारी में आपने फर्स्ट टाइम पे ये सोच लिया होगा कि ऑक्साइम का रिएक्शन यहाँ पे बैकमैन रीअरेंजमेंट के टाइप से सोचा होगा. PCl5 इज द reagent of बैकमैन रीअरेंजमेंट. So बैकमैन रीअरेंजमेंट में like PCl5H+, BF3, ZnCl2, Lewis acid we can use. So what will happen here? The oxygen will get like positive charge when it will be giving the electron to PCl5, and this OH group will be living as a living group. Now what will happen here? In the normal Bachmann rearrangement, you expand the ring, but here the OH group is present. Here the carbocation would be more stable. If I break this bond, here the carbocation would be more stable. The oxygen will stabilize, or oxygen will give the electron to this carbocation. So what will be the product here? This would be like this, cyanide. This will be formed as a cyanide. After that, we have used the Dipole, diisobutyl aluminum hydride. This is a mild reducing agent. We know that Dipole will reduce this CN into the CHO group. The acidic workup has already been done. After that, so the final product would be like this, dihaldehyde. This is the product P. What will happen next? Let's see. Dilute NaOH is used. In the presence of dilute NaOH, we all know that the aldol condensation would take place. These are the alpha hydrogens here. 2 alpha hydrogens are there. And carbon ion will be formed from here and it will attack on this carbon. Okay, let me make the product directly because this is a intramolecular aldol condensation take place here. So this will be a product. Very easily we can got this product, because when carbon ion will attack on this carbon, beta hydroxy aldehyde would be formed. After the elimination, we would get alpha beta unsaturated carbonyl compound. Further, NaBH4 is used in the presence of CeCl3. That is the important part. This is a alpha beta unsaturated carbonyl compound. Generally NaBH4 reduces the double bond as well, but in the presence of CeCl3, only the aldehyde group will get reduced into the alcohol. So this would be the product Q. Now what is next reagent? Look carefully. H plus heat followed by Na in liquid ammonia. So what will happen when you will heated it with the H plus? So it will get protonated, departure of leaving group and rearrangement of carbocation. Here you will get positive charge. After the positive charge, again the alkene would be formed. The product will be like this. Conjugated alkene. And again, next we have used Na in liquid ammonia. That is the Birch reduction. 1,4 addition of hydrogen will take place. And this would be the product. Okay. 1,4 addition. Earlier in the paper 1, we have also used this reagent. So what is the answer? What should be the answer? The correct option would be B. Let's check the answer. So option B is correct. Let's move on to the next question. What is the next question here? Bicyclo compound is given to you and MCPBA is used. After that aqueous NaOH and aqueous workup कर दिया है. So we can write this compound like this, bicyclo. And what MCPBA will do? MCPBA की प्रेजेंस में क्या होगा? एक आपके दिमाग में आ रहा होगा यार, या तो यहाँ पे इपॉक्साइड बन सकता है और आइदर यहाँ पे क्या बन सकता है, बेयर्स विनेगर ऑक्सीडेशन हो सकता है. बट दिस इज मोर रिएक्टिव. This is more reactive than alkene towards MCPBA. Ketones. This is the important point here. So the Beer's vinegar oxidation would take place here. तो oxygen को insert करना है हमें. Oxygen would be inserted here because it has more. This group has more migration tendency. Aqueous OH minus, then acidic workup. What would happen? It will get break, hydrolysis of ester take place. Very simple. So we can make, this is a 5-membered ring, okay, and this would be OH and this carbon would have COH. This would be a A. Now A हमें पता लग गया है. A is this product. Okay. After that we have used I2 in the presence of NaHCO3. What would happen? I2 के साथ iodolactonization would happen here. Cyclic halonium ion would be formed first. Then this OH will be internally attack on this 3-membered ring and this bond will get break. So we would get here the 5-membered ring again. So we can check the options. So here the iodine and here the OH. Both should be adjacent to each other. In the option D, we can clearly see. Check your answer, please. So let's see the answer. What is the given answer? Yes, option D is correct. Let's move on to the next question. Okay. This is a reactant given to you, Br2 halogenation करा दिया, allylic halogenation, allylic bromination. Allylic bromination हो जाएगा तो क्या होगा? OMe, this would be like this. Clear? उसके बाद देखिए what would form, आप समझ गए होगे इसको देख के, there will be a formation of Wittig reagent. Wittig reagent कैसे बनेगा? SN2 reaction would take place here and PHLI क्या करेगा यहाँ से? It will extract the hydrogen from here. तो what we would get? OMe like this, PH3 whole thrice. Now this is the product A. What is the next reagent given? It is reacting with the ketone. This is the acetophenone. Acetophenone के साथ कैसे reaction होगा? Nucleophilic addition. I am making the product directly. You know that this is the Wittig reaction. So what would happen? The product will be like this. OMe C double bond C, CH3, CH3, and again the phenyl ring is here. Okay. Now we have to use these two reagents. This is the product. This is not a product P. This is the intermediate, you can say, from A to B. Like we have drawn this. Let's see what will happen next. This is OMe. What is the next reagent? OSO4. Syn hydroxylation will take place here. Syn hydroxylation. And what is the next reagent? Dilute H2SO4 heat. तो आपको पता लग गया होगा इस टाइम पे क्या होगा? Pinacol rearrangement, Pinacol type rearrangement. This OH would get protonated first. You know that because it will give stable carbocation due to the plus R plus M effect of this group. यहाँ से water as a living group बाहर निकल जाएगा and migration of phenyl group would take place here. Then this oxygen would give electron to this carbocation. So what we would get here, the final product is like this. PHCH3 OMe. This is the product B. Multiple concepts has been asked in this question. First we have done bromination, Wittig reagent. After the Wittig reagent, you have formed the alkene, then OSO4 addition, and then dilute H2SO4. Let's check the answer. The option C is coming. But what would happen? Dilute H2SO4 is used, so this OMe, that is the ether, it would also get the protonated and get hydrolyzed. So when it would get hydrolyzed, this would be converted into phenol plus MEOH. Now let's check the answer. So answer C is matching with our answer. Okay, answer C is given. Okay, move on to the next question. This is a reactant given to you and heating. First the heating is done with the reactant. आपके दिमाग में क्या आया होगा सबसे पहले इस reactant को देख के? जैसे आपने एलाइल फिनाइल ईथर का क्लेजन कंडेंसेशन किया था, क्लेजन रीअरेंजमेंट किया था. This would be like this. On heating, this pi bond would move here, and this will attack on this. The same like allyl phenyl ether का जैसे हम क्लेजन रीअरेंजमेंट करते हैं 200 डिग्री सेल्सियस पे. What will be the product formed? Here, the double bond comes here, CH2, CHO. What would happen next? OSO4 again, double bond पे क्या आ जाएगा? After using OSO4, diols would be formed. Diols would be formed here, followed by NaSO3. That would do the basically protonation. And after that dry HCl is used, in this case, we can see clearly CHO and diols are present. So there will be a formation of acetal. This hydrogen, and this oxygen would get removed. Directly you can form the acetal formation. Okay. So what would be the final product P? Asking about the P. The final product could be like this. CH2 and this is the CH is double bond पे, इस diols पे हमने बनाया, तो it would be like this. You can simply form the product, final product. Let's check the answer. So option D is given. Very simple. Claisen rearrangement. You have to think about the Claisen rearrangement. After that, simple reagents are given. But first time पे आपको ये सोचना था Claisen rearrangement कैसे आएंगे. Okay. Now move on to the next section. Section 2. It has 4 questions and all of them are one or more than correct, multi-correct. This is question number 21. Okay. So this is we can clearly see the first reactant is alpha beta unsaturated carbonyl compound and the reagent given is Gilman reagent. And Gilman reagent, what does it, क्या Gilman reagent के कारण क्या होगा? Beta position पे attack होगा because hard acid HSAB, hard soft acid base concept. Okay. So here the delta negative charge will attack here and the formation of this Me would place here and this is the pH. What is the next reagent? Next reagent is pH SeBr. Again the substitution reaction would take place. We have taken a Se. Okay. So this is the enolate ion. From the enolate ion pi electrons would attack here and departure of living group would take place. ये ऑक्सीजन इसको इलेक्ट्रॉन दे देगा जब यहाँ पे पॉजिटिव चार्ज क्रिएट होगा. Me SePH, this is the phenyl. H2O2 is used next. तो H2O2 क्या करेगा? हीटिंग कर दिया. कोप एलिमिनेशन की तरह हम जैसे नाइट्रोजन ऑक्साइड बनाते थे उधर कोप एलिमिनेशन में it would be like this. SO minus pH CO and the syn elimination would take place here. Again this is the beta elimination, alpha beta. You can simply do this elimination. This oxygen will abstract this hydrogen and there will be a formation of this type of alkene. So what would happen here? What has happened here? See the next starting reactant and see this product P. We have basically introduced the methyl group here. Methylation किया हमने, beta carbon पे methylation किया. Okay. Now this is the product. After that P हमें पता लग गया है. P के बाद हमने क्या कर दिया? Ozonolysis कर दिया. Ozonolysis कर दिया Q and R. तो Q would be like this and R would be like this. Ozonolysis, simply reductive ozonolysis takes place. This is the Q because it is asking about. का भी आगे क्या करा दिया गया है? Cannizzaro reaction. Simply Cannizzaro reaction can take place here. OH minus followed by acidification. This OH minus would attack here. So this would be converted into acid when acidification will be done. Okay. So final product would be like this. And this would get converted into alcohol. Okay. This is the S, product S. Compound P is 3 degree. Compound P is 3 degree alcohol. क्या compound P 3 degree alcohol है? Incorrect option. Compound Q is acetone. We can clearly see compound Q acetone है. Dimer of compound S form 3 isomeric lactide. जब इसका dimer बनेगा तो क्या होगा? Dimer बनेगा compound S का. Compound S का dimer क्या बन सकता है? Lactide formation would take place. Esterification between 2 molecules. इन 2 molecules का जब dimer करोगे तो esterification हो जाएगा. And these are 2 different chiral centers. Different chiral center तो cis और trans बनेंगे. Cis form would be optically active and trans form would be optically inactive. तो 3 isomers would be formed here. तो it is asking dimer of compound S form 3 isomeric lactide. Yes, it is correct option. Degree of unsaturation in compound R is 5. Where is compound R? 5. 4 plus 1, 5 and 1 यहाँ पे 6. This is again incorrect option. So check your answers. Let's see the answer of this question. तो option B and C is given. Okay. तो आपको पूरा ध्यान रखना था इस क्वेश्चन के अंदर भी एक एक पॉइंट पे. Let's move on to the next question. Question number 22. Okay, the reactant you can clearly see on the screen, and the first reagent given is peroxy acid CH3CO3H. आप समझ गए होगे देखते हैं कि कीटोन की प्रेजेंस है, बेयर्स-विलिगर ऑक्सीडेशन होगा. Where the oxygen will be inserted? Tell me. Where the oxygen? Phenyl group has more migration tendency. तो PHO CO. Okay. After that, aqueous NaOH and acidic workup is done. That means hydrolysis. Hydrolysis of ester would be done here. OH and इसको H दे दो. Mechanism is not required here because acidic workup भी कर दिया है. तो क्या बनेगा? Phenol plus acid NO2 plus this would be converted into CH3COH. Okay, we have to decide which one is P and Q. The information given here is pK value of compound P is lower than the Q. So this is more acidic. So this would be P and this would be Q. Further, the compound Q is reacting with cyclic anhydride in the presence of AlCl3 followed by the acidic workup. You know how the phenol reacts. Compound P. This is the compound P. How it will react with the cyclic anhydride. This is the which reaction? Friedel-Crafts acylation. So इलेक्ट्रोफाइल थोड़ा बल्कि है तो पैरा पोजीशन से अटैक होगा, तो पैरा पोजीशन से यहाँ पे अटैक होगा. कैसे? कि ऑक्सीजन ने इसको इलेक्ट्रॉन दे दिया होगा LCl3 को, यहाँ पे कार्बोकेटन जनरेट हो गया होगा. तो क्या बनेगा हमारा? दिस इज CH2 CH2 COOH. Acidification is done. Okay. AlCl3 would leave as in the form of aluminium hydroxide. Again the ZnHg HCl is used, Clemmensen reduction. So this would get converted into CH2. CH2 at last, what is the given reagent? H plus heat. Very simple. You can protonate this का oxygen. ये लिविंग ग्रुप की फॉर्म में बाहर निकल जाएगा एंड इंट्रामोलिकुलर एसाइलेशन हो जाएगा. ओके. द प्रोडक्ट S वुड बी लाइक दिस. यहाँ पे रिंग फॉर्मेशन हो जाएगा एंड here the double bond would be formed. This is the product S. Okay. So you can clearly see first the Beers-Villiger oxidation process is used and after that Friedel-Crafts acylation. Let's check the answer. Only compound two compounds PQRS gives effervescence of CO2 when treated with NaHCO3. तो compound PQRS, P is this, ये दे देगा effervescence, Q नहीं देगा, P दे देगा, and the compound this compound is, what is this compound after the formation of ZnHg HCl and यहाँ पे आ गए थे हम ये compound क्या है हमारा R, and R would give Q and S bond give two compounds बोला है, तो this option is correct. 2,4-DNP test is given by only two compounds. 2,4-DNP test कौन देगा? S can give because of the presence of this ketone group and R भी दे देगा because of the presence of this ketone group. P नहीं देगा and S नहीं देगा, तो दो compounds दे देंगे 2,4-DNP test. Option B is also correct. Degree of unsaturation in compound P and R is identical but lesser than S. S में degree of unsaturation कितने हैं? 4, 5, 6 and P and R में कितने हैं? P and R में 4, 5, 6, and S में and R. Where is R? R is here. 4, 5, 6. Identical. All are having the same degree of unsaturation. This option is incorrect. P, Q, R and S are aromatic compounds. Yes, P भी aromatic है, Q भी, R भी and S भी aromatic है. Check your answers. A, B, D should be the correct answer. Yes, A, B, D is given. Okay, let's move on to the next question. The question is saying like डाइन्स ले लिया, डाइन्स की प्रेजेंस में SeO2 देन MnO2 का साथ हीट किया गया. तो एल्कीन्स की रिएक्शन SeO2 के साथ कैसे होती है? लाइलिक पोजीशन पे ऑक्सीडेशन, OH ग्रुप ऐड हो जाता है और MnO2 डाल देंगे तो क्या होगा? पहले तो OH ग्रुप ऐड हो जाएगा SeO2 की प्रेजेंस में. MnO2 क्या करेगा? लाइलिक अल्कोहल्स को क्या करता है? ऑक्सीडाइज करता है. तो लेट्स सी. फर्स्ट it would be the product. This is the product P. After that NH2OH NH plus is used. NH2OH NH plus is used. Again, what would happen? Nucleophilic addition reaction would take place. Oxime formation take place. And through H plus Bachmann rearrangement take place. And Bachmann rearrangement होगा तो क्या बनेगा? ये OH group protonate होके बाहर निकल जाएगा. And then the ring expansion would take place here. Here OH group is not present. तो जो उसको stabilize कर रहा था in the first question. तो here the positive charge come. On the positive charge we know that the water molecule will take attack. And the final product would be like this. 6-membered ring. एंड जब वाटर अटैक होगा तो OH आ जाएगा. दिस इज द प्रोडक्ट Q. आफ्टर दैट H2PD 120 डिग्री सेल्सियस. H2PD 120 डिग्री सेल्सियस हाई टेम्परेचर पे हाइड्रोजनेशन कराया है. वेरी सिंपल. ऑल द डबल बॉन्ड्स वुड बी रिड्यूस्ड. सारे डबल बॉन्ड रिड्यूस हो जाएंगे एंड यहाँ पे एक हाइड्रोजन आ जाएगा. हर जगह हाइड्रोजन 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 प्लेस कर देंगे. दिस इज द R. एंड व्हाट वुड हैपन आफ्टर R? BuLi CH3Br. BuLi एक्सेस में यूज किया, देन CH3Br 1 इक्विवेलेंट एंड एसिडिक वर्कअप. BuLi क्या करेगा बच्चों? BuLi इज अ स्ट्रॉन्ग बेस, abstract this hydrogen and this hydrogen. And after that we have used CH3Br 1 equivalent. After that acidic workup. तो BuLi ने दोनों हाइड्रोजन्स को एब्स्ट्रैक्ट कर लिया. CH3Br किससे रिएक्शन करेगा? 1 equivalent है तो. Because this is more nucleophilic and negative is more nucleophilic than oxygen negative. So CH3Br would react with N negative and after acidification it would get converted into OH. So this is the product S. Now we know the PQRS. Let's check the options. P is this. Incorrect. P हमारा क्या था? यहाँ पे कीटोन था. Q is this. Yes. Q हमारा यही था. S is this. Not. इसके साथ नहीं आ रहा था CH3. किसके साथ आ रहा था CH3? N के साथ. Option B and D. You can clearly see. Let's check the answer. You also check your answers. What you have marked in the question paper. B and D are given options. Correct options. Okay. Now, next question. Again multi-correct. Let's discuss this question. NaNH2. आप लोगों को पता है NaNH2 क्या करेगा? इस हाइड्रोजन को रिमूव करके माइनस कीटोन पे अटैक हो जाएगा. एल्कोहल वुड बी फॉर्म्ड. वाटर इज द एक्वस वर्कअप किया हुआ लास्ट में. तो P क्या बन गया हमारा? P हमारा बन गया PHC ट्रिपल बॉन्ड C COH एंड two CH3 are present here. This is the P. Very simple. First acid base reaction, then nucleophilic addition, and after the P, Lawson-Mundt reduction, या आप कह सकते हो कि एल्काइन है तो पार्शियल रिडक्शन लिन्नार कैटलिस्ट की तरह बिहेव करते हुए followed by H2CrO4. What would happen next? Let's see. If I use H2PD BaSO4, the alkene would be formed, cis alkene would be formed here. And the next reagent we have used here, H2CrO4. Most of the student would get stuck here because this is a tertiary alcohol. You would have think about that this alcohol would get oxidized or not. So this alcohol would get oxidized because it is in conjugation. So जब ये conjugation में होता है alcohol, you would have to write mechanism like this. पूरा complete mechanism लिखने की जरूरत नहीं पड़ती एग्जाम में जाके. You would have done it earlier in your classroom. Okay. So what would happen here? This double bond gets shift here and ऑक्सीजन क्रोमियम से कनेक्ट हो जाता है लाइक दिस हाइड्रोजन के साथ ऑक्सीजन क्रोमियम से कनेक्ट होते हुए एंड ये बॉन्ड तुम्हारा यहाँ से ब्रेक होते हुए इस हाइड्रोजन के साथ इंटरेक्शन होता है. ओके, सो व्हाट इज द नेक्स्ट प्रोडक्ट वुड बी फॉर्म्ड हेयर. यहाँ पे OH आ जाता है और OH ये सेकेंडरी अल्कोहल बन जाता है और ये सेकेंडरी अल्कोहल बनने के बाद कीटोन में ऑक्सीडाइज हो जाता है. And then CH double bond C, CH3, CH3. It would be like this. Okay? So this is the product Q. After that, 4 reagents are used here. Let's see. NaCN, HCN, CN negative, beta position पे, you know that. Beta पे attack होगा, 1,4 addition would take place in the presence of alpha beta unsaturated carbonyl compound. The product would be like this. Then acidic hydrolysis is take place. Yes, acidic hydrolysis. Acidic hydrolysis से क्या होगा? कार्बोक्सिलिक में कन्वर्ट हो जाएगा CN ग्रुप. After that NaBH4 and H प्लस हीट. NaBH4 क्या करेगा? इसको कन्वर्ट कर देगा, कीटोन ग्रुप को कन्वर्ट हो जाएगा हमारा अल्कोहल में, कार्बोक्सिलिक को रिड्यूस नहीं कर पाएगा. कार्बोक्सिलिक ग्रुप रिड्यूस नहीं हो पाएगा हमारा. एंड व्हाट वुड बी द प्रोडक्ट हियर? COOH एंड देन H प्लस हीट. ओके, COOH हो गया. H प्लस हीट करेंगे तो अगेन इंट्रामोलिकुलर स्टेरिफिकेशन वुड टेक प्लेस हियर. दिस वाटर मॉलिक्यूल वुड गेट रिमूव्ड. व्हेन दिस वाटर मॉलिक्यूल वुड गेट रिमूव्ड, you would get R. And what is the R? We can check from the option easily. Look at the option. The compound R and this cyclic ester दे रखा है. चेक कर लेते हैं ऑक्सीजन के साथ pH आ रहा है क्या नहीं. तो ऑक्सीजन के साथ ये pH आएगा. ठीक है, दैट मीन्स ऑप्शन डी इज करेक्ट. दिस इज इनकरेक्ट. Q क्या बना था हमारा, देख लेते जल्दी से. Q, वेयर इज Q? दिस इज द Q. तो Q इज इनकरेक्ट अगेन बिकॉज हेयर फिनाइल इज प्रेजेंट, बिकॉज CH3 हमारा फाइनल प्रोडक्ट में. एंड कंपाउंड P तो हमने बनाया था यही कंपाउंड P. ऑप्शन A and D. Compound P is here. Check your answers. Let me show you the correct answers. Option A and D are given. This is a last section 3. It has 8 numerical type questions. Let's discuss this. So, how many of the following reactions are correctly matched with their major product? So, you have to correctly matched reactions here. So in the first case, what would happen? It is like a, जो आपने कभी पढ़ा होगा कि इस पे विनाइलिक कार्बन पे क्या अटैक होगा क्या नहीं होगा, बट इट इज लाइक अ 1,4 एडिशन अल्फा बीटा अनसैचुरेटेड कार्बोनाइल कंपाउंड. When the oxygen would attack here of the methanol, this pi bond would move here and like this. And when it is coming back, O negative जब इलेक्ट्रॉन वापस देगा, ये वापस आएगा और इस Cl को बाहर निकाल देगा. ये डबल बॉन्ड वापस आएगा यहाँ पे और इस Cl को बाहर निकाल देगा, बिकॉज OMe तो बाहर निकल नहीं सकता, बिकॉज पुअर लिविंग ग्रुप है. So this reaction can happen. Okay. Yes. Next, NaNH2 liquid ammonia aromatic compound is given. You know that addition elimination mechanism तो follow हो नहीं सकता है, because addition elimination के लिए क्या होता है, electron withdrawing group must be present at ortho at para position with respect to leaving group, that is Cl here. The benzene mechanism would be followed here. तो मैं आपको ये बता देता हूँ बेंजाइन क्या बनेगा. ये बेंजाइन बन गया, ठीक है. जब इसका NH2 माइनस यहाँ से इसको लेके जाएगा तो बेंजाइन वुड बी फॉर्म्ड. एंड बेंजाइन की फॉर्मेशन के बाद आप कैसे सोचोगे कि NH2 माइनस या तो इधर अटैक करेगा या तो इधर अटैक करेगा. क्या होता है इसके RDS में, रेट डिटरमाइनिंग स्टेप में कार्बन आयन की स्टेबिलिटी को चेक करते हैं. यू नो वेरी वेल कि कार्बन आयन यहाँ पे ज़्यादा स्टेबल होगा इस कार्बन पे, बिकॉज ऑफ द माइनस आई इफेक्ट ऑफ दिस ग्रुप, एंड NH2 वुड प्लेस हेयर. अगेन दिस ऑप्शन इज ऑल्सो करेक्ट, दिस पार्ट इज ऑल्सो करेक्ट. In the next part, SNAR will take place here. S माइनस कौन से क्लोरीन को रिप्लेस करेगा? वेरी इजिली यू कैन टेल. बताइए सभी लोग, देखिए. तो S माइनस इस वाले क्लोरीन को करेगा, बिकॉज इसकी रिस्पेक्ट में ये ऑर्थो पे है और इस क्लोरीन की रिस्पेक्ट में ये कहाँ पे है, मेटा पे है. तो यहाँ से कार्बन आयन ज़्यादा स्टेबल बन जाएगा. RDS स्टेप इज द फॉर्मेशन ऑफ कार्बन आयन. तो देखते हैं कौन से क्लोरीन को रिप्लेस किया है. दिस क्लोरीन. इनकरेक्ट. यस, हेयर डबल बॉन्ड पे H2O2 OH माइनस की प्रेजेंस में क्या होता है, जस्ट लाइक आप MCPBA यूज़ करते हो या परऑक्सी एसिड यूज़ करते हो, आप इपॉक्साइड की फॉर्मेशन करते हो. इन द सेम वे H2O2 OH माइनस भी परऑक्साइड की फॉर्मेशन करता है. तो H2O2 OH माइनस दोनों रिएक्ट करके पहले O माइनस OH बना लेते हैं, एंड इट वुड अटैक हेयर एंड दिस डबल बॉन्ड हेयर, द कार्बन आयन फॉर्मेशन टेक प्लेस लाइक दिस. अब यहां पे जब कार्बन आयन बन जाएगा बच्चों, यहां पे पॉइंट सीखने वाला है कि कार्बन आयन जब बनेगा, क्योंकि पोजीशन उसने अपोजिट करके दी है क्वेश्चन के अंदर, इस चीज को हमें चेक करना पड़ेगा. कार्बन आयन बनेगा तो ये बॉन्ड क्या कर सकता है, इस बॉन्ड में रोटेशन फ्री हो जाएगा. इस बॉन्ड में जब रोटेशन फ्री हो जाएगा तो जब इपॉक्साइड बनेगा तो ये जब बॉन्ड रोटेट कर जाएगा तब इजिली इपॉक्साइड बन पाएगा. नहीं तो अदरवाइज ये दोनों सेम ग्रुप सेम साइड पे रहेंगे तो स्टेरिकली हिंड्रेंट रहेगा. तो दिस ग्रुप शुड बी at anti to each other for the formation of epoxide. Okay, so in the option it is anti to each other, so this can be happen, this reaction can be happen. Okay, now in MCPBA में क्या होगा, MCPBA में देखिए MCPBA के अंदर कंसर्टेड वे में मैकेनिज्म चलता है. कंसर्टेड वे में मैकेनिज्म चलता है तो क्या होगा, यहाँ पे इपॉक्साइड बन जाएगा और दोनों ग्रुप कहाँ रहेंगे, सेम साइड पे रहने चाहिए. यहाँ पे क्या दे दिया आपको, दोनों ग्रुप्स अपोजिट साइड पे दे दिए. दैट मीन्स दिस इज द इनकरेक्ट. विद द डाइल्यूट HCl व्हाट वुड हैपन हियर, H प्लस पहले डबल बॉन्ड से प्रोटोनेट होगा, बिकॉज कार्बोकेटाइन फॉर्मेशन यहाँ पे ज़्यादा अच्छा बनेगा कार्बोकेटाइन. फिर वाटर का अटैक हो जाएगा, water attack would take place here. OMe. Now again this would get protonated. ये प्रोटोनेट हो जाएगा, ठीक है, ये प्रोटोनेट हो गया, and this will depart as a living group, and this oxygen would give electron to this. So aldehyde formation can take place here. Again this is correct. How many statements are correct? 1, 2, 3, 4. 4 statements are correct. Let's check the answer. Yes, 4. 4 is given. Okay. Now, next question, 26. Alpha beta unsaturated carbonyl compound is there. This is the ester with the ketone, and NaOET is used. That is the strong base is in excess. So what would happen here? NaOET की प्रेजेंस में आप लोग समझ गए होंगे कि क्या करा होगा, अल्फा हाइड्रोजन को निकाल के यहाँ पे कार्बन आयन बना लिया होगा, कार्बन आयन के थ्रू बीटा पोजीशन पे अटैक होगा, वही HSAB का कॉन्सेप्ट, या हार्ड न्यूक्लियोफाइल इंटरैक्ट्स विद हार्ड इलेक्ट्रोफाइलिक सेंटर, सॉफ्ट न्यूक्लियोफाइल इंटरैक्ट्स विद सॉफ्ट न्यूक्लियोफिलिक सेंटर, तो इट वुड बी लाइक दिस। ओके, तो ये जब वापिस आ जाएगा तो हमारा फाइनल प्रोडक्ट क्या बन जाएगा इसमें, PHCO and this is the CO2Me, this would be like this, ये CH3, ये यहाँ पे आ गया PH। Again this is in excess, NaOET, what NaOET would does again, इस कार्बन आयन को बना लेगा यहाँ से, CH2 नेगेटिव बनेगा, और CH2 नेगेटिव बनते ही इस पोजीशन पे अटैक हो जाएगा, जस्ट लाइक इंट्रामोलिकुलर एल्डोल कंडेंसेशन। तो व्हाट वुड हैपन नेक्स्ट, दिस वुड बी लाइक दिस, CO2Me, यहां से CO, CH2 नेगेटिव, एंड दिस इज द PH, अटैक हियर, रिंग फॉर्मेशन वुड टेक प्लेस, 1 2 3 4 5 6, नंबरिंग कर लो यहीं पे ही, 6 मेंबर रिंग की फॉर्मेशन हो जाएगी, 1 2 3 4 5 6। सो एट द सेकेंड पोजिशन PH इज देयर एंड OH इज देयर, एलिमिनेशन H प्लस हीट करा हुआ है, चलो हम बाद में कर लेंगे वो, एंड देन फिफ्थ पोजिशन पे क्या है, CO2Me, एंड फोर्थ पोजिशन पे PH, ओके, एंड सिक्स पोजिशन पे आपका, सिक्स पोजीशन पे सेकंड पोजीशन पे क्या है, PH है, और ये दिस इज गेटिंग कन्वर्टेड इनटू OH ग्रुप, एंड सिक्स पोजीशन पे CO ग्रुप है, एंड देन H प्लस हीट, दिस इज द A, दिस इज द प्रोडक्ट A, H प्लस हीट किया हुआ है, H प्लस हीट से एलिमिनेशन वुड टेक प्लेस हियर, PH, ओके, हाइड्रोलिसिस है, इसका भी हाइड्रोलिसिस हो जाएगा साथ में, दिस वुड कैन कन्वर्टेड इनटू COH, और हीट भी किया हुआ है तो CO2 भी निकल जाएगा यहाँ से, बीटा कीटो एसिड बनेगा, बीटा कीटो एसिड के साथ CO2 भी निकल जाएगा, तो क्या हो जाएगा यहाँ पे, ओनली हाइड्रोजन विल लेफ्ट हियर, हाइड्रोजन, यहाँ PH है आपका, ओके। नेक्स्ट व्हाट हैव बीन डन, नेक्स्ट रिएजेंट इज अगेन H2O2 OH माइनस, अगेन इपॉक्साइड फॉर्मेशन वुड टेक प्लेस, ये किस डबल बॉन्ड पे इपॉक्साइड बनाता है, जो डबल बॉन्ड इलेक्ट्रॉन विड्रॉइंग ग्रुप के साथ लगा होता है, इजीली बना लेता है वहां पे, तो यहाँ पे इपॉक्साइड बन जाएगा, PH, what is asking in the question, the degree of unsaturation in final product B is, the degree of unsaturation 4 plus 4 8 9 10 11, du is 11, let's see what is the answer given, 11 is the correct answer, okay। next question is अल्फा पाइनिन दे दिया आपको, एक कंपाउंड, इसका नाम भी बताया है यहाँ पे, ओजोलिसिस, ऑक्सीडेटिव ओजोलिसिस इज डन हियर, followed by decarboxylation and reducing agent NaBH4 is used, मेजर प्रोडक्ट बनाया, देखते हैं, लेट्स सी व्हाट वुड हैपन हियर। रिडक्टिव कराने के बाद आप क्या करते हो, एल्डिहाइड वाले ग्रुप को कार्बोक्सिलिक में लिख लेते हो, यहाँ पे तो कीटोन बन जाएगा, दिस इज ए 4 मेंबर्ड रिंग, आफ्टर ओजोलिसिस आई एम मेकिंग अ प्रोडक्ट हियर, 4 मेंबर्ड रिंग के साथ CO CH3 and here 2 carboxylic acid would be there. This is the product after ozonolysis. Decarboxylation is done, this CO2 get removed. After decarboxylation, this CO2 get removed, this is the CS3. NaBH4 is used, it will reduce this CO group. What would happen, ये अल्कोहल के अंदर 2 डिग्री अल्कोहल के अंदर चेंज हो जाएगा. This is the product P. On product P, what is happening here next? H plus heat, dehydration. Dehydration would be like this. ऑक्सीजन वाटर की फॉर्म में OH बाहर निकल जाएगा, कार्बोकेटाइन जनरेट होगा, यहाँ से रिंग एक्सपेंशन होगा, रिंग एक्सपेंशन वुड टेक प्लेस. आफ्टर द रिंग एक्सपेंशन 5-membered ring would be formed here, 5-membered ring, and this is the एक मिथाइल हो रहा है हमारे पास लाइक दिस. यहाँ पे पॉजिटिव, यहाँ से हाइड्राइड शिफ्ट हो जाएगा, हाइड्राइड शिफ्ट हो जाएगा तो क्या होगा, हाइड्राइड शिफ्ट के बाद कार्बोकेटाइन यहाँ पे आएगा हीटिंग करने पे, और यहाँ पे एल्कीन बन जाएगा, वुड बी लाइक दिस. ओजोनलिसिस करा दिया, ओजोनलिसिस करा दोगे. कौन सा ओजोनलिसिस कराया, रिडक्टिव ओजोनलिसिस. रिडक्टिव ओजोनलिसिस के बाद क्या बनेगा हमारे पास, CH3CO C. 1 minute, this would be like this. Okay, this is adjacent to this one. Okay, these two groups would be adjacent to this and this. After the ring expansion, you would get like this. And this is the CH3, and then CH, CH3, CH2, CHO. Okay, after that what would happen, dilute NaOH heat is done, that is the intramolecular aldol condensation. तो when you will do the intramolecular aldol condensation, कैसे करोगे, यहाँ से कार्बोनाइन बनाओगे, कार्बोनाइन का अटैक यहाँ पे करा दोगे, formation of ring takes place. What is asking in the question, the mass percentage of oxygen in compound Q. When you would form the final product after the intramolecular aldol condensation, you can easily calculate the mass percentage of oxygen. Okay, let's check the answer. The answer is given in range. You would definitely get the answer. Now the question number 28, how many aldehydes excluding stereoisomers with molecular formula C6H10O having only one pi bond give positive tolerance test. एक ही पाई बॉन्ड है, ओके, पाई बॉन्ड एक होना चाहिए और आपको ऐसा चूज करना है कि जो पॉजिटिव टॉलरेंस टेस्ट दे. तो 6 मेंबर्ड का तो मैं नहीं चूज कर सकता क्योंकि वो कीटोन बन जाएगा, तो 5 मेंबर्ड से मुझे स्टार्ट करना पड़ेगा. तो 5 मेंबर्ड में दिस कैन गिव पॉजिटिव टॉलरेंस टेस्ट. 5 मेंबर्ड का और कोई केस नहीं बनेगा. लेट्स मूव ऑन टू दी 4 मेंबर्ड रिंग. 4 मेंबर्ड में कितने कार्बन एटम्स है, 6 कार्बन एटम्स है. दिस इज दी 6 कार्बन एटम्स, 4 मेंबर्ड विद एल्डिहाइड. This can be the case that can give positive tolerance. This can be the case that can give positive tolerance. And 4 membered का एक केस ये भी हो सकता है. This can be the case that can give positive tolerance. Now move on to the 3 membered rings. 3 membered ring में क्या होगा, six carbon atoms with aldehyde group. This can give, ब्रांचिंग कर देते हैं इसके अंदर. दिस कैन गिव, फिर एंड दिस इज 5. दिस कैन बी द केस, दिस कैन बी द केस. ओके, नाउ और क्या हो सकता है केस यहाँ पे. 3 मेंबर्ड में हमने CHO डायरेक्टली अटैच कर दिया, इथाइल लगा दिया. 3 मेंबर्ड के साथ CHO 2 मिथाइल ग्रुप्स, 3 मेंबर्ड के साथ CHO 2 मिथाइल ग्रुप्स इन पोजीशन पे. आपको एक्सक्लूडिंग बोला है, स्टीरियो आइसोमर्स कैलकुलेट करने की जरूरत नहीं है. 3 मेंबर्ड के साथ और कौन सा केस बन सकता है, दिस कैन बी द केस विद द 3 मेंबर्ड रिंग. ओके, दिस इज द केस. हाउ मेनी, 3 मेंबर्ड के साथ हमने ये भी बना लिया. और कौन सा केस हो सकता है, काउंट कर लीजिए. तो यू वुड गेट योर आंसर. जो टॉलरेंस टेस्ट पॉजिटिव देंगे 14. ओके, तो हाउ मेनी एल्डिहाइड्स विद द मॉलिक्यूलर फॉर्मूला हैविंग 1 पाई बॉन्ड give positive tolerance test. Next question 29. Aldehyde is given and thioalcohol, dithioalcohol is given to you. Again the thioacetal would form in the first step. In the first step, thioacetal would be formed here like this. 6-membered ring. BULI is used. BULI, what BULI would done? It will extract this hydrogen, acidic hydrogen you can say. BULI के बाद negative charge and interacting with D2O and followed by the Hg2 plus H3O plus. जब D आ जाएगा यहाँ से तो इस bonds का हाइड्रोलिसिस भी हो जाएगा साथ में, तो you would get COD. That means you have just replaced this hydrogen by deuterium. This is the product X. Now what would be the product Y? Again, in the product Y, thioacetal would be formed first. Okay, BULI is used. BULI is used. Carbanion would be formed. Carbanion would be formed. After that, CH2D Br is used. So it would attack on carbon and departure of living group would take place. And H2 Reni-nickel क्या करेगा? H2 Reni-nickel hydrogenation. So what would be the final product? CH2, CH2D. This is the product Y. What is asking in the question? What is the ratio of molecular weight of organic compound X to Y? तो आपको इनका molecular weight निकालना है, दोनों का molecular weight, उनका ratio लेना है. Very easily you can calculate. Let's check the answer to this question. तो it will come out to be 1. That means molecular mass दोनों का same आ रहा होगा. Molecular formula check कर लेंगे दोनों का. Both the compound must have the same molecular formula. C8H को count कर लीजिए, ठीक है? The molecular formula would be same. Okay. Or the molecular formula is not same, but the mass would be same. You can calculate easily because there is the oxygen. Molecular formula is not same, but mass would come out to be same. That is, the answer given is 1. That means the molecular mass would be same. Okay, you can easily calculate. Now next question is question number 30. Question number 30, what would happen here? Again the alpha beta. Beta keto acid नहीं है, COD दे दिया, अभी acid ही है. Hydrogen को deuterium से replace कर रखा है. तो what would happen? CO2 would remove first. So we would get this. NaBD4 is used. Further reagent NaBD4 and the solvent used is ETOD. Here from the D minus would attack here. Just like nucleophilic addition. और O minus को इस solvent से D मिल जाएगा. This is the D and this is the D. NaNH2 liquid ammonia use कर लिया है. NaNH2 liquid ammonia क्या करेगा? इस D को बाहर निकाल लेगा. Strong base है. Strong base जब D को बाहर निकालेगा CD3Br पे O minus के through substitution would take place through SN2 reaction. So what would happen? OCD3 and this is D here, this is D here. What is asking in the question? What is the mass percentage of hydrogen atom in major product P? This is the product P. You can easily calculate the mass percentage. Let's see the what is the molecular formula? 6 carbon, 7 carbon. How many hydrogens? 2 to 4 to 6 to 8 and one is 9 here. H9. And how many deuteriums? 5 deuteriums are there and with the oxygen. You can easily calculate the mass percentage of hydrogen. 9 divided by total molecular mass into 100. Let's check the answer and you can calculate and you can check your answer. This is given in the range 7.5 to 7.6. You would get an answer. The next question, question number 31. Question number 31, what is the reactant? Reactant is this, and reacting with Mg dry ether first. Mg dry ether के साथ क्या होगा? Mg Br बन जाएगा. Mg Br बनेगा, यहाँ पे नेगेटिव चार्ज डेवलप होगा. Let me make the first product here. Mg Br, negative charge would be here. Negative charge के थ्रू ये रिंग ओपन हो जाएगा बिकॉज दिस इज अ 3 मेंबर्ड रिंग. एंड जैसे रिंग ओपन होगा ये रिंग किसके साथ इंटरेक्ट कर जाएगा? CH3Br के साथ. ये नेगेटिव चार्ज वुड बी डेवलप हेयर एंड दिस वुड बी, एंड व्हाट वुड बी द प्रोडक्ट? CH3 CH2 CH2 C triple bond C PH. This is the product P. Here the conjugated alkene is used, is given. So what would happen here? Diel-Saldar reaction would take place here. Diel-Saldar reaction, okay? It would be reacting like this. Ring formation would take place. So ring formation, 2 double bonds will be present here, here and here, and इस double bond के साथ 2 groups लगे हुए हैं. एक ethyl group, propyl, and one is phenyl. This is the product. No, this is not a product Q because at the end reductive ozonolysis is done. Reductive ozonolysis करोगे तो क्या होगा? What would happen? Reductive ozonolysis के साथ देखो क्या होगा? Reductive ozonolysis. One equivalent is used only. One equivalent. So more electron density जहाँ पे होगा जिस डबल बॉन्ड पे उस पे reductive ozonolysis हो जाएगा because this is example of electrophilic addition reaction. Reductive ozonolysis के बाद आप product Q बन जाएगा very easily. And what is the number of sp2 carbon atoms in major product Q? We can easily calculate. Okay? जब आप reductive ozonolysis कराओगे तो कितने number of sp2 hybridized carbon atom होंगे? बहुत आसानी से बता सकते हो. इस फिनाइल के अंदर भूल मत जाना. Okay? तो आंसर गिवन इज 10. You will definitely get your answer after the reductive ozonolysis. Let's move on to the next question. That is our last question of paper 2 chemistry. So this is the ether given in the reaction and reacting with the excess of HI, and determine the total number of moles of HI that would react with 1 mole of above given compound. Above given compound में total number of कितने excess में HI used होंगे? Very simple, we can calculate here. जब ये वाला ऑक्सीजन प्रोटोनेट होगा, this oxygen would get protonate, this oxygen, तो यहाँ पे तो ब्रेकिंग नहीं हो सकती, तो यहीं से ब्रेकिंग होगी. एक HI यहाँ पे यूज हो गया. अगेन एक HI यहाँ से यूज हो जाएगा, ये OH हो जाएगा और ये I बन जाएगा. ये I, ये H, यहाँ पे H, दिस इज I. फिर इस केस में क्या होगा? यहाँ पे I नहीं आ सकता. इस फ्रॉम हेयर इट विल बी ब्रेक. सो हेयर H and here I. How many moles are used here till now? 1, 2, 3. In this case इधर से भी ब्रेकिंग नहीं हो सकता, ना ही उधर से ब्रेकिंग हो सकता, बिकॉज दोनों साइड से ना ही SN2 प्लेस हो सकता है, ना ही SN1 हो सकता रिएक्शन में. तो व्हाट वुड बी दी प्रोडक्ट? फाइनली आई एम मेकिंग हेयर OH, here I, here OH, and plus PHOH. ये प्रोडक्ट्स भी साथ में बन रहे हैं. CH2I, इसके 2 मोल्स बन गए. अगेन 3 moles are till used. Again this would react with HI. It would get converted into I. Again HI, ये I हो जाएगा. Vicinal diiodides would be formed here that are unstable, we know that, even at the room temperature. So I2 will be removed here. Okay, it is not benzene. Okay, let me draw the product, this product again. because we have missed the, this is the product OPH, OH, and this is the product, okay, and this is the product. When it is used with the HI, this would get converted into I, again vicinal diodides, a double bond would come, 4 moles till now used, 4 moles are till now used, and here the double. Again the double bond would react with HI, you would get the iodo here. Okay, though finally 5 moles of HI are used, the answer to this question should be 5. Let's check the answer. The answer given is 5. So students, hope this was a very informative session for you, and I know you would have done some silly mistakes in this paper as well. So try to learn from those mistakes. Stay connected, keep learning, keep practice. Now I'm going to invite the mathematics faculty. Our Megrang sir would take session. Megrang sir, please take a charge for further session.
Yes, okay, sir. So sir, how was the chemistry paper? I think it's quite tough this time, right?
Yeah, paper 2 was quite tough, but the complete package is here. Student have learned lot of things from this paper.
Okay, usually
if the student is getting I would like to say to students, if student is getting 30% or 40% marks in paper 2, that is considered as a good score. Okay. And in paper 1, if you are getting more than 50% marks, that is considered as a good score.
Okay,
yeah.
So usually chemistry is easy, but this time
it was tough.
Okay.
Moderate to tough level. Yeah.
Okay, thank you.
Thank you.
Okay, good afternoon students. So I'm Megrang Jain and we'll continue with the maths part of the open test 2 paper 2. Okay, so let's start. Yeah, so first section 1, single correct questions. This is the first question. In this question we're given function r defined from r to 1 to infinity. Similarly, g is also defined with the same domain and codomain. And they are given as differentiable functions which satisfy this differential equation, right? This is the differential equation plus g square into f dash plus this is f into g dash, right? This is given to us as 0. So you have to solve this differential equation. We can solve this quite easily. This is an exact differential of f cubed by 3, but this is coming out to be differentiation of f g square by 2, but this is not the differentiation of g square by 2, right? So what we can do is to convert this into an exact differential, well, we can play around with f, right? We can multiply or divide the whole equation by f, because this term is not an issue, right? So well, if we multiply the whole equation by fx, like this, so we can do that because the output of fx is never 0, right? It's given as codomain as 1 to infinity, so we can multiply whole equation by fx. It's a non-zero term, and because of this is now an exact differential of d by dx g square into s square by 2, right? So now you can integrate this whole differential equation. It's f to the power 4 by 4 plus g square s square by 2, and this is equal to a constant c, that is the arbitrary constant. So from here we can say that the sum should always be a constant, right? So obviously, I mean, f is there in both of these expressions, so f has to be bounded so that their sum is always a constant c, and if f is bounded, then g into f should also be bounded, right? And well, that is our option D. F is bounded and fx into gx is also bounded. Let's check the answer. Yeah, correct option is D. Okay, so once you form the exact differential, this question is quite easy, right? Okay, let's move on. The next question. We are given a functional equation, and to help with the constant, I guess, we are given a value of f of 2 equal to 11. We want to find the value of f of 3. Okay, so what we can do here, This is a polynomial. The important part is this is a polynomial satisfying this functional equation. So I think you guys must be getting a hint from here. We see fx into f1 by x. It's a standard result. What I can do here is just if I factorize this is fx minus 3 into f1 by x minus 3, because both the fx and f1 by x have coefficient 3, and we'll have an extra 4 on the RHS because their product gives 9, right? So now it is starting to look like the result that we know, right? That gx into g1 by x equal to gx plus g1 by x. So what we can do here, if we just take the substitution, it will probably get us a result a lot quicker, because we have the coefficient 4 here. So what we want to do is f of x minus 1 by 3. I'll just take it 2, but if I do, no, I'll take the 2 on the LHS instead. Okay, so when I do the substitution, so f of x minus 3 is twice gx minus 1, right? So when I put it here, like this coefficient gets cancelled out, and we are left with the standard result that gx minus 1 into g1 by x minus 1 equals to 1. So that implies that gx is the standard polynomial function 1 plus minus x to the power n. We want to find fx here, so we'll just substitute that here, and from here we'll get fx as f of x minus 3 whole upon 2. This is coming out to gx minus 1. So fx is something like 3 plus minus 2x to the power n. Here we just have to figure out what is the value of n and what is the sign here, plus or minus, right? And for that we are given the data that f of 2 equals 11. So when we input that here, f of 2, it's coming out to be 3 plus minus 2 into 2 to the power n. When you put it as 11, we get the function here, right? That first of all there should be plus sign here, and n should be equal to 2, right? Because 3 will go here, it will become 8. 8 by 2 is 4, so 2 to the power 2 is equal to 4. So the function f is 3 plus 2x square. And in the question, we're just supposed to find the value of f of 3, right? So 3 plus 2 into 9. So this is 2 into 9 is 18 plus 3, 21. The answer should be option A. Let's check the answer. Yeah, option A. So this was again a simple question based on the standard result that we know of. Just there was a bit of substitution, similar to what we had in the paper 1, right? Okay, in the next question, we are given the value of this limit and we have to find a plus b. So usually in these types of questions, well, we can go through the LH rule, or we can use expansions. I see x into sine bx in the denominator, so most likely if we apply LH rule, we're going to do that twice. Maybe it's just better to use an expansion here. Let's see. The numerator we can write as sine ax minus, and it's going to break this. So sine ln e to the power x, this is minus x minus ln cos x upon x sine bx, limit x tending to 0. This is given to us as half. To apply the expansions everywhere, we know the expansion of sine. We know the expansion of cos. I'm writing the expansion of cos here. 1 minus x square by 2. I'm not writing any further expansion, see, because what is happening here in the denominator, again I did like this using a standard limit. So this is the standard limit, it goes to 1. We're just left with the x square, right? So in the numerator we don't want any more terms apart from x square. So I'm limiting myself and the expansion to just having the terms with x square, no further powers are required. So sine of ax, this is ax. I'm not writing the next term, that is because that is a cubic term. This is minus x, and I have the expansion of ln 1 minus x square by 2. So that expansion is going to be, the first term is going to be minus x, which is minus x square by 2 here. Now the further terms, the next term is going to be a degree 4 term, right? Minus x square by 2 whole square. So I'm not writing that term because we don't need that term. And in the denominator we just left with x into bx, that is bx square. Now again, the same concept that we had in paper 1, that if this limit is going to be defined, the term with the x, this should be 0. So from here we get the value of a should be 1, so that this cancels out and we have a finite value of the limit. So this is x square by 2, x square will get cancelled out, and we'll have 1 by 2b should be equal to half. From here we also get the value of b as 1. So a is 1, b is 1. We wanted to find the sum of a plus b. A plus b is going to be 2. That is option B. Let's check the answer. Yeah, option B. Okay, so in maths we are lucky, right? The first 3 questions were quite easy. In fact, very less calculation. Okay, the next question. A function fx is given to us like this. It's quite a lengthy function. It says that it is differentiable for all x belonging to R. We know that this is a modulus function, right? 2 does not impact whether the function is differentiable or not. This modulus function is not going to be differentiable at these 10 values. We already know this. This is quite a basic result, right? A lot of times a question has been asked in mains and advanced as well based on this result. So you can see this graphically as well very easily. And but their product is differentiable. So that means the product can only be differentiable if these 10 values are roots of gx equal to 0. Right? That is the only way that this function is going to be differentiable for all x. Okay, but gx is given to us as a 9-degree polynomial. ax9 plus bx6 plus cx cube plus d. But you already know that there should be 10 roots, right? So the only way that this is going to happen is that, I think you guys guessed it, gx is 0. It's a 0 function. It's 0 everywhere. Because a 9-degree polynomial cannot have 10 distinct roots. So the only case that this has more than 9 roots is that it is an identity function. That is, it is 0 for all values of x. Okay, so if gx is 0, then obviously fx is just this minus 2, right? Because this whole thing is 0. This whole thing is 0, so we are just left with minus 2. So f dash of minus 1. F dash of minus 1, f is a constant. So differentiation is always going to be 0. So answer should be option B. Yeah. So again, quite a standard and easy question, right, with minimal calculation. So the first 4 questions were quite easy. So this paper is, I think, is a lot easier than the first paper. Okay, section 2, multi-correct. The first question is, A is given to us as a set of first n natural numbers. Okay, so A is basically 1 till n, right? And a function f a to a is injective, and we are given this relationship. Okay, so that means that the output of f of 1, that we can say that the distance of f of 1 from 1 is the same as distance of f of 2 from 2, so until the distance of f of n from n is also the same. Okay, so what we want is, for n equal to 25 there is only one such function. For n equal to 26, okay, so basically we are given different values of n. We are given 2025, 2026 and 2027. For this we basically have to find what type of functions can we form. How many functions can we form here? The function should be injective and it should satisfy this relationship, right? So I think the easiest function that we can form here is the identity function, right? Such that f of x equal to x for all values of x, right? So that is the easiest function that we can form. If n is odd, I think this is the only function that will be able to form, because we have to make sure that the distance of f of 1 from 1 is equal to the distance of f of 2 from 2, so on. So for odd values of n, there should exist only one such function. Apart from this function, apart from the identity function, no other function would be possible which satisfies this condition. And you can think of it logically. There is only no other way to think of it really. But if n is n is odd, n is 2027, then f of 1 has to be 1. So this is wrong. Now when n is even, when n is 2026, what we can do is we can take the input pairwise. For example, obviously this is one such function that we can form. with even value of n. Apart from this, what you can say is, if we pair up f of 1 with 2 and f of 2 with 1, like this. So the distance of f of 1 from 1 is 1, distance of f of 2 from 2 is also 1, and again the next two elements will again pair them such that their output we can interchange in this manner. In this manner we can create a function. Okay, so this function satisfies all the conditions. It is injective and it satisfies this relationship. Apart from this, we can play pairwise by making a distance of 2 as well. For example, we can have f of 1 as 3, f of 3 as 1. So that, now the distance that we're talking about here, the distance is equal to 2. And similarly, f of 2 we can have as 4, and f of 4 we can have as 2. Since we have an even number of terms here, we can just pick them pairwise. And we can keep on doing this till the maximum distance that we can have. We have a total of 26 terms here, right? So we can pair f of 1 with 1014, and f of 1014 can have as 1. Similarly, f of f of 2 we can have as 1015, and f of 1015 we can have as 2, and so on. So these are the total possible functions that we can form, having distance 0, having distance 1, 2, 3, so on till 1013. So total of 1014 such functions we can form. So for n equal to 2026, we are able to form a lot of functions. So this is wrong. For n equal to 2026, the maximum value of f of 1 can be 1014. Yeah, that is the last function that we formed here. So B option should be correct. So the answer should be A and B. Let's check the answer. Yeah, the answer is A and B. So this question was a bit tougher to solve. तो इसमें थोड़ा बहुत logically ही सोचना है. It's not a standard question, it's not a standard condition. You will have to think of it a bit logically, but it's still manageable, I think. Okay, the next question. It says that the two curves touch each other, and we're given two parabolas, and we have to find the value of lambda in all the options. Okay, so well, we can go about it two ways. Either we can solve the equation and see whether they're touching or not, or we can also go through slopes, right, dy by dx. But for the slopes as well, we have to at least get the points of intersection, right? So we have to solve the equation anyways, right? So okay, let's try to solve this equation. Instead of directly putting y as lambda x square minus x in this equation, it will create a 4-degree equation, right? I don't want to do that. What I see is if I just directly subtract these two equations, I'm just directly subtracting these two equations like this. So I see a term coming out as common here, right? This is x square minus y square, and this is, I can take x minus y as common from both of them, right? What I'll be left with x plus y here, and minus 1 from these two terms. And I have x minus 1 RHS as well, right? So when I factorize everything, I'll get, this will give me minus 1, and I'll bring everything on the left hand side. So this will be minus lambda times x plus y minus 1 equal to 0. So either I'll have x equal to y, or I'll have this as 0, right? So this is minus 1 equals lambda times x plus y minus 1. Okay. If x is equal to y, I'll have to solve this further. This is my first possibility. I'll just substitute y equal to x here. So I'll get x equals lambda x square minus x. This is a quadratic in x, right? Lambda x square plus x times minus lambda minus 1. And what I want is, I want a condition for which these two curves touch each other. So if they touch each other, so this quadratic should give me only a single value, right? So for that, what I can do is I can just put the discriminant as 0. So when I do that, I get lambda plus 1 whole square minus 4 times lambda into 0. It should be 0. So I'm getting a value of lambda as minus 1 here. Okay, and similarly I'll just solve the other equation as well. Again, I can get the value of y from here. I can just substitute that value of y here. So y I'm getting here as this is going to be minus 1 minus lambda x plus lambda upon lambda. So I just put everything on the LHS. So minus 1, this is minus lambda x, this is plus lambda whole upon lambda. I'll put this equal to lambda times x square minus 6. So I'm just putting the value of y as here again. I'm just solving these two equations. Again, I'm getting a quadratic, right? And we already know now what to do. Just like in the previous situation, the coefficient of x is minus lambda square and plus lambda from here. And apart from this, the constant term is lambda 1 minus lambda. Okay, I'll take the discriminant here as 0. So this is lambda square, I'll take as common, into lambda minus 1 whole square minus 4 lambda square into 1 minus lambda. So this is getting factorized as lambda square. I'll take it as common and I get lambda minus 1 whole square minus 1 plus lambda. So lambda square into, this is lambda square minus lambda. Equal to 0. No, I made a mistake here. Let me just correct it. This is going to be just a moment, minus 1 minus lambda x plus y by lambda. Okay, this is correct. Lambda x square minus x. This factorizes lambda square x square plus x minus lambda square. This is fine. And I'll have plus lambda over from there plus 1 minus lambda. Yeah, this is fine. Again, I got a quadratic. I'm just creating discriminant here. I took lambda common here. So lambda square, and I'll be left with lambda minus 1 whole square minus 4 times this into this 1 minus lambda. I take lambda square as common. So this is lambda minus 1 whole square, which is correct, minus, okay, so minus, okay, I forgot 4 here, right? I'll just correct this. I forgot this 4 here. So minus 4 times plus 4 lambda. Okay. So lambda square, this is coming out to be lambda square plus 2 lambda. And this is minus 3 because we have plus 1 here over. Okay. Yeah. So the values of lambda that I'm getting here is lambda is 0, and from there this is the quadratic equation which is getting factorized in plus 3 and minus 1. So these are the values of lambda. Here what do I see is if I put value of lambda as 0, if I put value of lambda as 0, you know, this becomes y equal to 0 line. This becomes x equal to 0 line, which are the x-axis and y-axis respectively, right? So obviously we'll reject them because the curves will not be touching each other for lambda equal to 0. So the possible values of lambda that I have here is minus 1, 1 and minus 3, right? So let's check the options now. Yeah, the sum of values of lambda, the sum is coming out to be minus 3. This is correct. The greatest value of lambda is not 3, that is 1. The least value of lambda is coming out to be minus 3. So this is also wrong. And the greatest value of lambda, yeah, the greatest value is coming out to be 1. So this option is correct. So the answer should be A and D here. Let's check the answer. Yeah. A and D. So this question involved a bit of calculation, right? And even I made a mistake in the calculation, right? So under time pressure, the students can make some mistake in this question because the calculation is a bit lengthy, right? Okay, but yeah, we were able to save time from the previous questions. This is the first question that we faced that was a bit lengthy. Okay, next question. We are given a relationship between the sequence of terms an, and well, we want to find whether the sequence is periodic, what is the maximum value of the sequence for n tending to infinity, and what happens if a1 is 6. Okay, so let me just simplify this a bit. Maybe I'll be able to find the value of an from here directly. When I rearrange this, I'll take this on the LHS and then take out the terms common. So a n plus 1 is coming out to be a n upon a of n minus 2, right? And well, if a1 is equal to 3, if I put a1 as 3, then a2, this is 3 upon 3 minus 2, which is again 3. Again, similarly, a3 is also will come out to be equal to 3, right? And so on. So yeah, if a1 is 3, then the sequence is coming out to be periodic. This is true. What happens if a1 is equal to 6? Okay, let's check this out. If I put a1 as 6 here, then a2 will come out to be 6 upon 6 minus 2. This is 3 by 2. Okay, then similarly I'll find a3 here. Let's see whether it comes out to be periodic. 3 by 2 upon this is 3 by 2 minus 2. So it's coming out to be a negative value in fact. This is minus 3. When I put minus 3, I'll get minus 3 upon minus 3 minus 2, 3 by 5. So I'm getting all the values different. So I will not be able to directly say from here whether it's periodic or not. So we'll have to solve this for this one, at least for option D. Okay, let's try to figure out another way to solve this question. What we can do, we have this coefficient 2, right? So what I'm thinking here is, let's do a substitution. Let's first see what happens if we divide by n into an plus 1. When we do that on both the sides, this will come in the denominator, and similarly I will have 2 upon a of n. So I've divided both the sides by this term. I'm getting a coefficient of 2 here, and I'm getting a plus sign. See, if I got a negative sign here, right, and the coefficient would have been same, so what would have happened is, जब हम सबको ऐड करेंगे वो सब कैंसिल आउट होते चलेंगे, ऐसे कई बार देखा हमने सीरीज प्रोग्रेशन में. So to do that, what I'm thinking is, if I probably make a substitution here, for example, let's say bn, because I want a minus sign. So what if I make the substitution minus 2 to the power n? So here we'll have 1 equals 1 upon an plus 1. An plus 1 will be, this will come out to be bn plus 1. This will be minus 2 to the power n plus 1 plus 2 times bn into minus 2 to the power n. We'll divide both sides by minus 2 to the power n plus 1. So this is coming out to be 1 upon bn plus 1. And we'll have one minus sign over here because we have divided minus 2 to the power n plus 1. Yeah. So see, in this manner we are able to form difference of two terms, right? And well, I think you guys must have guessed what will happen now. I'm just going to continue this on the next page. This was minus 2 to the power n plus 1, right? Right. So when I put n as 1 here, so I'll get 1 by b2 minus 1 by b1. This is 1 upon minus 2 square. Similarly, 1 by b3 minus 1 by b2, I'll get 1 by minus 2 cube, and so on. 1 by Bn minus 1 upon Bn minus 1. This will be 1 upon minus 2 to the power n. When I add all of them, these terms will get cancelled out, right? Sorry, not B1. B2 will get cancelled out from the next one. B3 will get cancelled out from the next one. Similarly, Bn minus 1, this term will get cancelled out from the previous term. So from here we'll have 1 upon Bn minus 1 upon B1. This is basically sum of a GP, right? With the common ratio 1 by minus 2, right? I'm just writing the sum of GP here. Right? So first term is 1 by 4. The common ratio is 1 upon minus 2. And we have the power, the number of terms is n minus 1 upon 1 minus 1 by minus 2. Right? So you can solve the RHS, right? And I'm just reverse substituting the value of Bn because we want A of n here. So I took the substitution An as Bn by minus 2 to the power n. So Bn will be minus 2 to the power n into An. So I'm just substituting the value. And this will be 1 upon minus 2 into A1. And on the RHS well, we can simplify this by taking the LCM. Something like this upon minus 2 to the power n minus 1, and we have a 3 by 2 in the denominator as well, 1 plus half, right? Okay, so from here we can basically find the value of An, right? And then we can answer the equations. And remember, this is for the situation when the sequence is not periodic. A1 is equal to 3, we solved it in a different manner. And well, we can just substitute the value of A1 here. For A1 equal to 6, well, we can solve we can just put A1 as 6 here, and we can see well, it will not come out to be periodic, right? It's not coming out to be periodic. So well, option D is obviously wrong. And we want to find the value of An as n tends to infinity. Well, you can simplify this a bit, but I'm just going to focus here a bit because we don't actually need to get An here, we just need to find the limit value. I'm just going to apply the value of the limit. First I'm just multiplying the whole thing by this minus 2 to the power n. So this is a big term. This will come out to be like this plus this 1 by minus 2a1, right? And this whole term is going to be multiplied by minus 2 to the power n, right? So this is 1 by an. So if I put limit n as infinity on both the sides, what will happen is that the RHS, see, although this is a finite term because you have 2 to the power n minus 1 in numerator and denominator as well, this is also a finite term, right? But this term is a very big term, right? Minus 2 to the power n. So when you put n as infinity, this will come out to be plus or minus infinity based on the sign, the value of n, right? N can be an even number and an odd number, so it will come out to be plus minus infinity. But limit n tending to infinity a of n in both the situations will be 0 here, right? So the limit value n tending to infinity a of n, we're calling it as L. The maximum value is 3, that is when a1 is taken as 3. This is correct. But this value is going to be 0 for all values, for all the rest of the values of a1. So this is also correct. So the answer should be A, B and C. Let's check. Yeah. The answer is A, B, C. So this question is also a bit tough, on the tougher side. But yeah, we have these sort of questions, we have seen these sort of questions now coming in mains as well, right? So we have to have a bit of practice about these questions as well. Okay, on to the next question. Question number 40, which of the following statements are correct? Okay, so all the options are disjoint from each other. You have to solve each and every one separately. This is also looking to be a bit lengthy question. Okay, so function is defined on 0 to 1 to r. It's differentiable, f of 0 is 0. And we are given this relationship. And we want to know whether fx is identically 0 or not. Identically 0 means is 0. and I think there should be an x here. Identically 0 for all values of x belonging to 0 to 1. Okay. Okay, so if we solve the inequality given to us, we can do definite integration on both the sides, right? When we integrate the function from 0 to x, we'll have f of x minus f of 0 here. So f of 0 is given to us as 0. And on the LHS, when we do definite integration from 0 to x, obviously the area is going to be 0. So by using definite integration, we can say, yeah, this inequality corresponds to that f of x should be greater than or equal to 0. And this should be true for all x in 0 to 1, right? That is the whole domain for the function. And similarly, when we solve the other inequality, this sort of inequality has been asked multiple times in advanced, right? What we usually do is we want to create an exact differential here. So for this purpose, we just multiply both the sides of inequality by positive term, right? Usually an exponential term. So here what you can do is दोनों साइड को e की पावर माइनस 2x से मल्टीप्लाई कर देते हैं. And the reason for that is so that we have an exact differential here, like this. If you see this, this is nothing but d by dx of e to the power minus 2x into fx, right? And we want this to be less than or equal to 0. That means this is a decreasing function, okay? Again, we can, we want fx, right? So what we can do is we can again integrate both the sides within the limit 0 to x. When we do that, the integration of LHS is obviously this, and the integration of RHX is going to be 0, right? This is coming out to be e to the power minus 2x into fx minus 0. So from here we're getting fx is less than or equal to 0. From here we had fx is greater than or equal to 0. So the only way that both inequalities are going to be satisfied is that yes, fx is identically 0. This is the only possibility. Okay, so yeah, the A option is correct. On to the option 2. Option B says that if fx is this function, it is an increasing function for all x belongs to R, then we can say that a square minus 3b plus 15 is less than or equal to 0. It's clearly a question of we just need to find f dash x, right? So let's do that. Fx is given as x cube plus ax square plus bx plus 5 sine square x. Okay. Now when we do f dash x, we're getting 3x square plus 2ax plus b plus, this is going to be 10 sine x cos x, which we can write as 5 sine 2x. Now this is supposed to be an increasing function for all x. Then the minimum value of this function should also be greater than or equal to 0, right? I think most of you have solved a question of this format sometime or the other. So the minimum value of the function is going to be when we put sine 2x as minus 1, right? Like this. This should be true for all x. Okay. Now what will happen is this is a quadratic, and we know, well, this value of quadratic with the leading coefficient as positive. This is going to be greater than or equal to 0 when we have d less than or equal to 0. So from here we'll get 2a whole square minus 4 times 3 times b minus 5 is less than or equal to 0. 4 will get cancelled out. A square minus 3b plus 15 less than or equal to 0. So we're getting this condition which is in fact given to us as here, a square minus 3b plus 15 less than or equal to 0. So most of the students, I think, would have, marked this option as correct, but in fact, this is not a correct option, because see what is happening here, we actually took the lowest possible value of the function 5 sine 2x to make sure, this always stays as positive. But for some possible values of a and b, for example, if I take a as 1 and b as 5, for this set of values of a and b, this function will not be an increasing function for all values of x, right? So it is very difficult to identify this type of question, and such questions haven't been asked in advance for a long time. So, well, this is not a correct option. Okay. For the option C, we are given that x to the power a is less than or equal to a to the power x for all x belonging to 1 to infinity, and a also belongs to 1 to infinity. So both of them are parameters, x and a, right? And we want to find the number of values of a that satisfies inequality, whether it's only 1 or more than 1. So I think most of you guys would have identified this as a case of a to the power b is less than b to the power a. We usually do this sort of questions by taking fx as x to the power 1 by x, right? So if we take the function fx as x to the power 1 by x, I think you guys must have done this at some point in application of derivatives. The maxima for this function comes out at x equal to e, right? So you can say that at f of x will always be less than or equal to f of e for all x being positive, right? So x to the power 1 by x is always less than or equal to e to the power 1 by e. If we raise both sides by ex, we'll get x to the power e is always less than or equal to e to the power x. And that is what we wanted to figure out, right? We wanted to figure out when is x to the power a less than or equal to a to the power x. And as you can see from this function, this is true for only one possible value of a, which is equal to e. So yeah, this is correct because this is true only for a equal to e. Okay. On to the last one. It says that fx is a differentiable function in 0 to infinity with f of 0 as 0. F dash x is increasing function. Okay, so f double dash x is positive. I'll just write it here. Then gx is defined like this, and we're to find whether gx is decreasing function. Well, I think in this case you can just take a simple example. Gx may be decreasing as well, but a simple example will just suffice. For example, if we take a sort of let's say a cubic function, right, x cube. So x cube, in a x cube, f double dash x. We also want f double dash x to be greater than 0 because we want it an increasing function, right? So f double dash x positive can be for, let's say, x to the power 4, right? So if we take fx as x to the power 4, it satisfies all the given conditions because f of 0 is 0, f dash x is an increasing function for x to the power 4, and it will become x cube, right? And x cube is not a decreasing function, right? It's an increasing function. So this is wrong. Okay, so the answer should be A and C. Let's check the answer. Yeah, the answer is A and C. So again, quite a lengthy question. So the single correct questions were quite easy and involved less calculation, but these multi-correct questions involved quite a high calculation, right? Okay, on to the next part. We have the numerical questions now. The first question, fx says that it's a differentiable function with f double dash x modulus less than or equal to 5 in 1 to 10. Fx assumes its maximum strictly in the interval 1 to 10. Okay, so the maximum value of fx lies in the interval 1 to 10. We want to find the maximum value of this function, f dash 1 modulus of that plus mod f dash 10. Okay, so for this, well, if fx assumes its maximum in 1 to 10, we can say that f dash c will be 0 for some c in 1 to 10. Basically, you are saying that c is the point of maxima. Why I am saying this? Because see, these types of questions in which we are given the double derivative, we want to find the value of f dash 1 or f dash 10. In fact, we want to find the maximum value. The inequality is involved. So usually we solve these types of situations in LMVT, right? So what I'm going to do is I'm applying LMVT in the interval, let's say 1 to c, from LMVT I can say that there exists a point c dash, let's say, and I'll apply LMVT on f dash, in fact. So f double dash c dash should be equal to f dash c minus f dash of 1 upon c minus 1. So I have applied LMVT on f dash x for the interval 1 to c, because here I will get f double dash, and I know an inequality on f double dash, and f dash c I know that is 0. So I will basically get the value of f dash 1 from here. So I am getting the value of f dash 1, this is minus of c minus 1 times f double dash c dash, where c dash is some point in the interval 1 to c, right? Similarly, I'll apply LMVT in the interval c comma 10, because from there I'll get f dash 10, which is required. So from here I'll get f double dash c, let's say c double dash, this is f dash 10 minus f dash of c upon 10 minus c. Again f dash c I know is 0. So from here I'll get the value of f dash of 10, right? So f dash of 10 is coming out to be 10 minus c times f double dash of c double dash. So I want the sum of these modulus values. So mod of f dash 1 plus mod f dash 10, this will be equal to f dash 1, I got this. So the modulus of this c minus 1 is positive. So this will be mod of f double dash c dash plus f dash 10 is equal to this value. Again 10 minus c is a positive value, because c is obviously less than 10. So this is 10 minus c times mod of f double dash c double dash. And because I want the maximum value, for the maximum value I can see, you know, these terms are positive, right? So to maximize LHS, I want to maximize RHS, and I'm given that the maximum value of f double dash is always 5. So I put in the value of f double dash as 5. I'll get that this is always less than or equal to, c will get cancelled out, I'll get 45. I'll just write it a bit more clearly. This is 45. So the value of k here is 45. I want to find the value of k by 5, which is obviously 9. So 9 should be the correct answer. Yeah, this is the correct answer, right? So it's a simple application of LMVT, and I'm sure that most of you must have done a similar question of this type once. Okay, on to the next question. I want to find a 4-degree polynomial which satisfies this condition, and I want to find f of 3 minus f of 5. Well, in this question we're not given much of information. So you can just take a random 4-degree polynomial like this, and you just satisfy the given condition to get the answer. But yeah, one thing that you can do here is, see, we given the value of f dash and f triple dash, both the points are 4, right? So what I can do is, I can instead of doing this, I can take f of x in this manner. I can write its expansion about 4. It's still a general 4-degree polynomial. What it will do is, I basically shifted my polynomial by 4 units. So इससे calculation हमारी थोड़ी आसान हो जाएगी, because see f dash x, this is obviously 4 times ax minus 4 whole cube plus 3 times b x minus 4 whole square plus 2 times c x minus 4 plus d, right? We're given f dash of 4 is 0. So that basically gives us that d is 0, because all these terms individually are 0. So we can do this question a bit smartly to reduce some calculation. And similarly, we're given f triple dash 4 is minus 24. So f double dash x is, we'll have 12 here. So we have 12 here, x minus 4 square plus 6b x minus 4 plus 2c. So f triple dash will be 24a x minus 4 plus 6 times b. This is f triple dash, and we given f triple dash at 4 is minus 24. So f triple dash at 4 will reduce this term to 0. 6b equals minus 24. So the value of b is coming out to be minus 4. Okay, so we got these two results. This is the only information that we'll get from here. We want to find the value of f of 3 minus f of 5. Okay, so f of 3 minus f of 5, see, this is also quite useful, right? Because if we take the polynomial as this, so f of 3 and f of 5, this term will come out to be the same, right? It will be a and a. So the two will get cancelled out here. We'll be left with this term because we have an odd power here. So f of 3 will have minus b, and similarly in f of 5 will have plus b here, but we're putting a minus sign here, right? So it will be minus b as well. Similarly, f of 3, this will be c. In f of 5 also we'll have c here, so it will get cancelled out. F of 3 will be minus d, and f of 5 will also be plus d, but we have a minus sign here with f of 5, so minus d as well. And e will again get cancelled out. So f of 3 minus f of 5 is this. This is minus 2 times b plus d. B plus d is minus 4. So this value will be 8. So the answer should be 8. Oh yeah, the answer is 8. Right? So in this manner you can save up a bit of time, and this sort of manipulation is quite useful, especially in functions chapter, right? Okay, on to the next question. We given a function fx, and it says that different values of greatest integer of fx are the roots of this quadratic. Then we have to find the value of 2k plus mu. So we basically have to find range of fx, then we'll figure out what are the different values that the greatest integer fx can have. Okay, so well, finding range is easy in this question. You can just separate out the numerator like this first, plus 3 by 2 times 2 fractional part of x plus 1, right? Because this is half, this is a constant, right? So now finding range will be easy here, because we can say that the denominator 2 fractional part x plus 1, this denominator varies from 1 when fractional part x is 0 to 3 when fractional part x is 1, but fractional part x is always less than 1. So we'll have open interval at 3. So 1 upon this will be 1 by 3 to 1. We can just multiply this by 3 by 2 and add half here as well, right, to directly get the range of fx. So in this manner we can get the range of fx here. This is 3 by 2 times 1 by 3, so this will be half plus half, it will come out to be 1. And similarly 3 by 2 plus half, this will come out to be 2. So the range of fx is 1 to 2, right? So this is one way that I found range. You guys must know many other ways to find range. You can also do it, if you want, you can also do it using periodicity. The period of this function is going to be 1, so you can just simply find the range in 0 to 1, right? Anyways, fx is coming out to be in this interval, and so the greatest integer of fx, it can only have the values 1 and 2, right? So 1 and 2 are the roots of this equation, right? So very simple calculation. We can just do the, we can just find the sum of the roots and product of roots. This is 3, and the product of roots, that is mu minus mu by 3, this should be equal to 2. From here we'll get the value of mu and k. K will come out to be 9 by 2 minus 1, so 7 by 2. We want to find 2k plus mu. 2k is 7, mu is 6, so the answer should be 13. Let's check the answer. Yeah, the answer is 13. So rather simple question again, right? So this paper looks a bit easier, quite easier in fact compared to paper 1, right? Okay, then the next question. A function is defined from r plus to r plus. It's a differentiable function, and we're given this relationship that this has at least 5 real roots. Okay, so fx equal to 1 by x cube. This is nothing but fx equal to 1 by x cube, right? We can do this because our domain is given as 0 to infinity. Okay, so x is not exactly 0. So this has at least 5 real roots, and we want to find the roots of this differential equation. Okay. Okay, so what we can do is either we can integrate this, and then after integrating we can get the value of fx and put it as 1 by x cube, because we know the number of solutions of this equation, or we can differentiate this as well to try to find a relationship like this, right? Differentiation is a bit easier as compared to integration, so I'll do differentiation, right? Because we want to save time, right? So fx equal to 1 by x cube. Now even while differentiating this, if I directly differentiate this, I'll not get f double dash x into fx easily. It will involve a bit of manipulation. So what I'm thinking is I'll take log, because I'll reduce this term as well while taking log. It will be minus 3 ln x, right? Because you have x to the power minus 3 here. Now I'll differentiate both the sides. This will be f dash x by fx. So if I have f dash x and still I have fx here, because I want fx into f double dash possibly, and this will be minus 3 by x. I'll differentiate it again. On a LHS I'll apply the quotient rule. So it will be f double dash x into fx minus f dash square x upon f square x, and this is 3 by x square. Right, so I'm getting terms like this. Okay, I just cross multiply this. When I cross multiply, I multiply x square with this and 3 with this. So I'm getting these terms, right? This is x square f double dash into f minus x square f dash square minus 3 f square. This is coming out to be 0. Okay, so if I just rearrange these terms, right, I'll take these terms on the RHS. I write it like this. So I'm getting the exact equation that is given to us. Okay, so basically what is given to us is, if I take this as a function, if I take fx minus 1 by x cube as a function g, if I take this function as g, I know this function has 5 distinct roots. So this is basically what is being asked from me, is basically this is g double dash, right? So if g has 5 distinct roots, then according to Rowe's theorem, g dash x should have 4 distinct roots between them, and similarly g double dash x should have 3 distinct roots between them, at least 3 roots between them. So the answer should be 3. Let's check the answer. Yeah, the answer is 3. So it was a bit of manipulation and based on the Rowe's theorem, right? Minimum number of roots. Okay, the next question, 45. We want to find the number of points of discontinuity for this function. We have greatest integer of 2 to the power minus x square into greatest integer of 2 to the power x square. Okay, we know that we saw a question based on this concept in the paper 1 as well, right? So again, I'm just going to apply the same concept. We know that greatest integer of any expression is discontinuous whenever that turns an integer value. So 2 to the power x square, the range of this function will be from 1 when we put x as 0 here, right? And the maximum value of this function will be when we put x as 2 or minus 2 here. So 2 to the power 4, which is 16. So this function will have its values from 1 to 16. Okay, fine. So there are multiple possible points of discontinuity, and now to analyze the function, what you can do is you can take a case that, let's say if 2 to the power x square is an integer, what is going to happen? Well, f of x, since we're taking 2 to the power x square as an integer, so you can directly write this value as 2 to the power x square, and this is clearly 1, right? So whenever 2 to the power x square is an integer, the fx is equal to 1, and if 2 to the power x square is not an integer, so what is what will happen is, well, we can write this as, let's say 2 to the power x square minus the fractional part, right? Like this. Again, this is 1 and this is fractional part of 2 to the power x square into 2 to the power minus x square, which I can write it like this. Now see, 1 is an integer, right? It will come outside the greatest integer function. What we're left with is minus fractional part of 2 to the power x square upon 2 to the power x square. Now 2 to the power x square, the fractional part of 2 to the power x square, it always lies in the interval 0 to 1, and 2 to the power x square itself lies in the interval 1 to 16. So this ratio will always will lie in the interval 0 to 1 always, right? And we have a minus sign here. So the greatest integer of this value will always be equal to minus 1, right? So this will be minus 1 for all x in the domain of the function. So this is 0 because we have a 1 here, so 1 minus 1 is 0. So basically whenever 2 to the power x square is an integer, the function will be equal to 1. Whenever 2 to the power x square is not an integer, the function will be equal to 0. So the points of discontinuity will be all those points where the function turns an integer value, right? So we just have to basically find when 2 to the power x square turns an integer value. 2 to the power x square will turn 1 at x equal to 0 only, right? Apart from this, there are 14 more integers from 2 to 15, right? So 2 to the power x square, this is equal to 1 at x equal to 0 only. Apart from this, it can vary from 2 to 15. For all these values, we'll have two possible values of x, right? Similarly, because x square, we have to find the value of x square. So there are two possible values, plus and minus values, whenever 2 to the power x square is 2, 3, 4 till 15. So these are 14 numbers, 14 into 2 roots from here and plus 1 root from here. So there should be a total of 29 points of discontinuity. Okay, let's check the answer. Yeah, the answer is 29. So a bit tricky question. I think maybe some students would forget the negative values of x square. Okay. Okay, let's move on. The next question. We given the function fx is defined piecewise like this. We are given a function gx which maximizes the function fx with a parameter, and we want to find number of points in this interval where it's not differentiable. Let's analyze function fx first, because to get the function gx we have to analyze fx. I'll define fx piecewise as x when x is less than 1, and well, for x greater than or equal to 1, I can break this function into two parts, right? First of all, greater than or equal to 1 till 2, this will be negative, this will be positive. So it will be x minus 1 plus 2 minus x. So x minus 1 plus 2 minus x will be 1. Similarly, when x is greater than or equal to 2, both the modulus will open with a plus sign. So I'll have 2x minus 3. So well, the function looks quite easy to plot. So I'll just plot the graph here. Plotting graph helps us quite a lot, right? So at x, for x less than 1, I have the graph of y equal to x like this. For x in 1 to 2, I have y equal to 1 like this. For x greater than or equal to 2, I have the line 2x minus 3. 2x minus 3, yeah, it will start from 2, 1 point, and it will be having a bit greater slope than this line, right? So the graph will look something like this, the graph of fx. Now on to the graph of gx. We given that when x varies from 0 to 2, we have to maximize this function f, right? And what we're doing is, this is a 1 unit gap, right? X minus 1 to x. So x is varying by distance of 1 unit, we can take t anywhere from x minus 1 to x such that f of t is maximized. So how do we do this is, we take the lowest value of x as 0. So basically t varies from minus 1 to 0, right? Let's say minus 1 is here, 0 is here, 1 is here. So from minus 1 to 0, I just plotted minus 1 here as well. So from minus 1 to 0, we know that the graph is basically y equal to x, right? So basically, as we vary x from minus 1 to 0, the maximum value of the function will always be given at the highest point, right? Similarly, when we increase x by a bit, say x at half, so this varies from minus half to half, right? So again, from minus half to half, again the maximum value will always be given by the highest value of x, that is for t equal to x. And this will be done till we have x as 2, right? Because again the fx is increasing here, from 1 to 2 is a constant, right? So again we can say the maximum value is again at the highest point. So for all x in 0 to 2, the graph will look something like this only, right? I just remove this. Okay, so the graph will look something like this only. Till 2, and well, from 2 to 3 were already given that the graph is 3 minus 6. So 3 minus 6 will look a straight line like this, passing through the point 3. Okay, the graph is only till 3, right? So we wanted to find the number of points of non-differentiability in 0 to 3 closed interval. Clearly, there are 2 points of non-differentiability. So the answer should be 2. Yeah, 2 is the correct answer. So this question is easier if you analyze it graphically, right? Okay, 47th question. Well, we are given a rather complicated function. Okay, we have polynomial, trigonometric, signum, logarithm, modulus, exponential, everything is there. Okay, and a, b, c, d are some constants. A is greater than 0, and we are given the value of the function at a few points. We have to find minimum number of zeros of the equation f(x) equal to 0. Okay. Okay, so well, to find the minimum number of zeros, what you can do here, what I'm seeing here is that, you know, if I check f of minus x, see this is an odd function, right? So f of minus x, I'll just take minus common here. Similarly, f of minus x, sin x, sin 2x, and sin 3x, all of them are odd. So minus will again come common from here. X square is an even function, but signum is an odd function. So is sin, right? So signum of sin will also be an odd function, right? So minus will come common from here as well. Logarithm x plus under root 1 plus x square, this is also an odd function, right? You must have done this in class, it's there in the package as well. Overall, this is also an odd function because we will have minus x plus 1, and this is minus x minus 1. So minus x minus 1 modulus of that will be x plus 1 only. This is an odd function, this is an odd function, and minus x, yeah, this is also an odd function. So 3 odd functions multiplied, we'll have a minus common from here as well. So f of minus x is coming out to be minus fx, which means this function is odd. And what that means for us is, we are given the value of the function at 3 points, minus 7, minus 5, minus 2. So we also have the value of the function at their positive counterparts, that is 7, 5, and 2, right? Because this function is odd. So I'm just plotting a possible graph here. F of minus 7 is given to us as 7. F of minus 5 is minus 5. F of minus 2 is 3. It's an odd function, so f of 0 must be 0. You can also, you know, just put in x as 0 here, you see, because each and every term is coming out to be 0 at x equal to 0, right? It's also a property of odd function, right? If 0 is in the domain of the function, f of 0 should be 0. And similarly, because it passes through minus 2 comma 3, so it should pass through 2 comma minus 3 as well, because it's an odd function. Similarly, for minus 5, we should have 5 comma 5. And for minus 7 comma 7, we should the function should pass from 7 comma minus 7 as well. Okay, apart from this, we also can observe that at x equal to infinity, see, the most dominating term will be this ax to the power 17, because at x tends to infinity, this limit will tend to a constant value, right? This will again, the x will get subtracted out. So the most dominating term is actually x to the power 17. So, and a is given as positive. So at infinity, the function should tend to infinity, so somewhere here, right? Similarly, since it's an odd function, so f of minus infinity, you can directly say should be minus infinity. So the function should pass through all these points. And we have to find the minimum number of zeros for the equation fx equal to 0. Now, see, if we draw any curve passing through these points, the minimum number of zeros that we can have, you may find that the minimum number of zeros is 7 in this manner, right? But see, you cannot actually apply IVT here. See, this is not a continuous function. This is continuous, right? This is trigonometric, this is continuous. This also is a continuous, right? This will be also continuous, it's defined for all x. The problem lies here. Signum of sin x. This is a discontinuous function. It will be discontinuous at every point where sin x is 0. In fact, it has a jump discontinuity. So see, it will be discontinuous at x equal to pi. Pi will lie, I'll just remove these marks. So sin x will be 0 at x equal to pi. So x equal to pi will lie between 2 and 5, right? Let's say here. And similarly, 2 pi will lie between 5 and 7, somewhere here, let's say. Similarly here as well. And obviously between 7 and infinity, infinite values, infinite multiples of pi will lie, right? So let's call it 4 pi, let's say. Now what we can do is, since we want to find minimum number of zeros, well, the function has to pass from 0, right? It's also continuous because we have x square here, right? So the function is continuous at 0. It will go like this, but the function is discontinuous at pi. So what will happen is, in fact, what can happen is, we can select a, b, c and d in such a manner that the function is the value of the function at pi, it was a bit lower somewhere here, for example, but as soon as we had x equal to pi plus, the function simply skipped this value and the function directly came here, because signum has a jump discontinuity. So the signum can directly make the function value from here. And similarly, again, we can have a jump discontinuity at 2 pi, and the function can simply skip this root and come here. Same thing at 4 pi as well. The same thing on the left hand side as well. So we can simply skip these roots on the right hand side and the left hand side. So the minimum number of roots can be only this 1.0. This has to be a root of the function. Apart from this, there may not be any other root. We can just simply select a, b, c, d in such a manner that we can skip all these roots in between, right? So the answer should be equal to 1. Let's see. Yeah, correct answer is 1. So this was quite a tricky question. In fact, you find all these points, you figure out that the function is odd, which feels quite good, right? And you figure out all these points even at infinity and minus infinity, and you can just join all these, and it looks very good, right? In fact, I think you must have solved quite a few questions based on IVT in such a manner, right? But well, this was quite a tricky question. Okay. Right. So the last question, it says that we are given a sequence of real numbers in which a1 is given to us, an plus 1 is given to us, and we want to find the value of this limit. Okay, so let's see. Well, the sequence is looks quite easy to solve. Let's see. When I take the LCM there, it gives us n plus 4 upon n plus 1. So, well, I can say that, when I put the value of n as 1, so this is 5 by 2 times a1. Similarly, a3 is 6 by 3 times a2. a4 is 7 by 4 times a3. a5 is 8 by 5 times a4, and so on till an. I want an is an minus 1 times, this will go to n plus 3 upon n. I think you guys must be observing that when we multiply all of them, so obviously a2 will get cancelled out, a3 will get cancelled out, and so on. An minus 1 will get cancelled out with the previous term. In fact, even in these constants, right, the constants will get cancelled out. See, 5 is getting cancelled out from here. Similarly, 6 will get cancelled out from its next term, right? So basically what we're left with is, on the LHS we're left with an only. All these rest of the terms have cancelled out. On the RHS, there is just this a1. Apart from a1, we'll have these 3 terms in the denominator, 2, 3 and 4. Similarly, we'll have these 3 terms left over in numerator as well. So this is n plus 1, n plus 2 and n plus 3. In this manner. A1 is given to us as 12. I just put in the value of 12. So I got my an, right? N plus 1, n plus 2, n plus 3 whole upon 2. I want the summation of 1 by ak. Okay. So 1 by ak, this is nothing but 2 upon n. I'll just put k instead of n. K plus 1, k plus 2, k plus 3. And I want to find the summation of this. Well, this is quite an easy question of series progression, right? You break the 2 in the numerator as k plus 3 minus of k plus 1. And well, you can just split it as a difference of 2 terms. Everything will get cancelled out. I mean, most of the terms will get cancelled out. And summation 1 by ak you'll have as 1 upon k plus 1 into k plus 2. From here, I just write everything after summation, right, directly. You guys must have done this sort of questions a lot. What I'll be left with, since the summation is from 1 to n, so this term will be left with 1 and 2, right? So when we put as k as 1, so I'll be getting 2 into 3 minus 1 upon n plus 2 into n plus 3, right? It says easy sum. When you put limit n as infinity, will give, this will turn to 0. You'll be left with this term, that is 1 by 6. So the value of L should be 1 by 6. 42 times of that is 7. So the answer should be 7. Let's check the answer. Yeah, the answer is 7. Right? So again, standard question, if you just figure, not afraid of the sequences, right? So this sequence is a bit easier to find out. Okay, so this was the end of the paper 2 discussion. I hope you guys benefited from this a lot. The mathematics part was, well, quite a lot easier than the paper 1. And well, if you again, if you just power through paper 1, don't get disappointed, and you'll be able to score a lot better in paper 2, right? Okay, so good luck from my side, and well, I hope for the best for you all. Thank you.